Very good morning to all the dignitaries, professors, and the participants present today. On behalf of MIT University, Uttar Pradesh, Department of Computer Science and Engineering, MIT School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for keynote address for Confluence 2022 12th International Conference on Cloud Computing, Data Science and Engineering. Even though we would have liked to invite you to our campus and have the keynote session in person, current world scenarios impede us from doing so. Luckily, we are grateful to have the opportunity to keep keynote session in a virtual mode so that our students can reap the seeds from the knowledge gathered in this session. Today, I am profusely elated to take the opportunity to invite our honorable speaker, Professor Dr. Bhuvan Anilkar. Sir is a professor in University of South Florida, Sorrento, Manatee, USF FSM, and is a founder and consultant at Method Science. Sir has contributed diligently in the field of and a man of distinct vision. Sir, you are an idol of knowledge, experience, and inspiration to many in the domain of banking, financial, insurance, government, and telecommunications. With so much on board, sir, you hardly need any introduction. Having done winner of the Computer World Object Developer Award in 1995, Consensus IT Professional Award in 2006, and IT Writer Award in 2010. Sir has contributed with his technical acumen and distinguished work. Sir, we invite you on the platform to share a few words with us. Sir, kindly proceed.
Thank you, Dr. Rashmi. I'm presuming I have got about 20-25 minutes. Is that right?
Okay, sir.
All right. So let me share my screen and take you through some of my thoughts. I will reduce this window so you have a clear view. So first of all, always honored and elated at being invited to speak to MET. I am not new to MET. My name is Bhuvan Unhelkar, and the topic today is artificial intelligence and business optimization. And I'm going to talk very little. I might just mention data analytics, but I want to talk about how we combine and why we should combine data analytics and process modeling. So here is my brief introduction. Although I'm a part of University of South Florida, somewhere in east coast of America, I am actually a Sydney UTS graduate. This is my Guruji, and I am sitting right now at my home in Sydney, Australia, as I have a one semester sabbatical. And this particular activity of presenting this keynote is a part of my enjoyable task at the sabbatical. I'm also a life member of Computer Society of India and Baroda Management Association. This was my first experience at visiting your wonderful campus. I was there in Confluence 2020, which was the 10th event, and it was a face-to-face event. And I still have great memories of being in that wonderful big hall at MIT University. I'm not remembering all the staff here and faculty, but there were some with whom I had taken pictures, and also over here as in the part of the big hall and a social event worth remembering. I also want to thank Dr. Ashok Bansal, who has become a good friend of mine, and we are working together to see if our students, because I consider myself a part of MET, can get bigger and better opportunities at a global scale. Last year, 29th of January, I delivered my second keynote address, which was related to environmental intelligence. And there it was online and was delivered from Florida. And I had talked about the phenomenal importance and the correlation between using data analytics and its impact on environment. And I'm very proud of this certificate for my work last year. These are my research interests, of which I'm going to talk a little bit about AI and business optimization. But I have mentioned others in case you get interested. The idea of a keynote is not to really provide you with phenomenal training or coaching or contents, but to establish a relationship with you all, depending on your areas of interest, and see if we can collaborate further, do some more research. What are the latest thoughts around the world in a particular field? But data science is my key area of interest, and all of this follows from data science. I have some material from Art of Agile Practice, which I had talked about even earlier. I also use my book Software Engineering with UML in teaching software modeling. By the way, all the books are freely available to my students in USA. These are some of my other books that may interest you. Enterprise architecture interests quite a few people. This was written with Keith Sheringham, who has visited Delhi and a couple of universities there and would love to come to MIT as well. So these are some of my activities, some of my work. This particular book was written during COVID drama, and Professor Tad Gonsalves had his sabbatical. He has an Indian background, but he actually lives and works in Sophia University in Japan, where he has an AI lab, and he has been doing supervising PhD research in autonomous driving and obviously now autonomous droning, which is a large branch of AI. So today, I want to introduce two important keywords that go with data science. One is agile and the other is process modeling. And both have come from different directions. Agile primarily from software development methods such as Scrum, and process modeling from business analysis as a profession, and I will talk about that a little. But those are the two new things, or those are the two things that I want to talk with data science, and they don't seem to be that regularly discussed in the field of data science. Now we know, so this is a little bit of known material, that everything to do with data and its usage, and today data is phenomenal. This particular meeting is getting recorded, and that will generate maybe 20, 30, 40 megabyte or even more of data. And so many of these companies started off without their own contents. They are only data companies, and I don't even need to read out the names. But my key stress in today's keynote is that really, if you talk to business people who nowadays are also technology people, and many of you students who are doing your management should not limit yourself to finance or marketing or HR or law, because all these fields are capitalizing on AI. But if you look at the sponsors of a project in data analytics, machine learning, AI in general, they will tell you that please don't talk about technology, don't talk big data, NoSQL, Hadoop, Apache projects. Don't tell us that. Tell us how data will add value to the work we do. So what I'm presenting to you today is my view on how we as complete professionals can add value to the business. So in terms of some terminology, if you like, so AI is the well-known term, but its intersection with big data is what I call machine learning, because big data is so big and it's not just large. That means it is not just the size of the data, but the semi-structured or unstructured nature of data, the blogs, the sensor data. We drive using Google Maps and it produces data, and the airplane flies using technology that produces half a petabyte of data for just one flight across the Atlantic or the Pacific. So we need technologies to make sense of that big data, and that is what I call machine learning. Business also makes huge amount of analytics using statistical methods. Linear regression is the starting point, but you have even more basic classification, categorization, support, confidence, lift, K-mean, K-medoids, so many very fundamental techniques and definitions of how to make sense of data. When it is coded and put inside a software package that is primarily looking at the descriptive aspect, I call it business intelligence. And as you can see, data analytics includes everything. So what then is the difference between what I was doing? I started my career in 1982 as a COBOL programmer, and some of you may not even know what COBOL is. It's commercial business oriented language. It was a procedural language. And I used to work for the payroll applications in Telco in Pune, which is now Tata Motors. And we used to have data in flat files, and we would sort it and more sorted and print it in certain order and produce information which will be of value to the user. But in the world of big data, which is not just large data, but complex data, unstructured data, we want information, but we also want the story behind the data. And that is what will be used by our user to do what? To make decisions. Why to make decisions? To add value to their business. So that's the goal. So AI, we understand as artificial, which means it is artificial and not natural. And the end game, when we bring agility, when we bring process modeling, and when we bring other things that I'm not discussing, like cyber intelligence, cyber security, performance, APIs, service-based analytics, and so on, we still have a need for natural intelligence, the balancing act. So AI is AI and not NI. This is a picture diagram I have taken from Professor Tad Gonsalves's earlier book, wonderful work, What is Artificial and What is Intelligence? And he has actually defined how intelligence includes learning. So when we get a Python code, when we write a Python code, to not just process data, but to look at the output of the data and use that as a feedback loop in the next iteration of processing, we are exhibiting, or we are getting our system to exhibit a certain amount of intelligence. Those of you who have worked in AI ML know that when you have a data and when you have a ML code, you slice the data into at least three parts: the training, the validation, and the testing, and then the rest of the data. So Why is there a need to divide data into training data and test data? Because we are trying to incorporate intelligence in our solution. It has to learn, therefore we need training data. Then we have to validate our code. So there is validation data. And then we have to also see how it performs, what the users are going to do with it. And that is our testing data. Now, there are three well-known terms that you have come across when it comes to AI modeling. One is descriptive, the other is predictive, and the third is prescriptive. Now, what are businesses doing? So I've got here some use cases, which are well-known use cases, all primarily from US. Walmart, phenomenal amount of data. eBay, 9 petabytes of data, all in, by the way, Hadoop. And Facebook, nobody, and now it's of course Meta. So this is a 1-year-old slide, but this data is of no interest to business unless it helps them improve their decision making. So in case of Walmart, can it answer this question? Should I put the kids' toys of age 3 to 6 in the lower front rows as an example? eBay, who is our most reliable customer? In fact, Walmart has many case studies, like one which says baby nappies and beer bottles should be kept together, because data analytics tells business that young fathers are sent by their partners to pick up a pack of nappies and they buy beer. Or young boys who have become father recently go to pick up a pack of nappies and pick up beer. Very interesting, something that only data analytics can tell. So really the idea is, can a business decision be made with that data? So we have our three models. Let me just jump there given the shortage of time. And all these data are based on correlation, not causation. So our models cannot answer why. Remember that. That is why it is recommending that baby nappies should be kept near beer bottles. It cannot answer. That is natural intelligence. And also when we deploy with a balancing act. So my popular analytical models are descriptive, which work on historical static data; predictive, which combine historical data with some current data in order to make prediction. And this is not very heavily used right now, even though it is very, very popular, and that is prescriptive analytics, where the system is not only predicting what will happen, it is also suggesting a course of action. Now, I want you to keep these three words in mind when we talk about providing value to business. Whichever machine learning models we produce, or we can use tools like Azure Workbench that some of my students are using to do some visual programming without going into the nitty-gritty of Java or Python. We want to improve the speed of decision making. A particular loan application can take 3 weeks for a home loan. Can it be reduced? Yes, with AI and ML, it can come down to 3 hours. In fact, car loan applications could be approved online. What about admission of a patient in a hospital? With what speed can a patient be provided relief, especially in COVID days? AI and ML can help do that. Hotel occupancies, talk about accuracy. Hotel occupancy, a hotel is never fully occupied. And right now, if there is a prediction to be made, even if they go wrong, 50, they say hotel will be occupied 50% capacity and they only end up with 35, it is still not bad as a prediction, because it may end up being 10% occupied, as is happening with flights. And then how many decision points? So these are all analytical discussions. business analysis discussion. These are all architectural discussions, and young programmers learn machine learning code but miss out on these. So here is one of my flagship diagrams. We really want to move from data to intelligence, and the way to do is from data to information to business processes and process modeling, business process modeling, then knowledge discovery through decision science, and then intelligence. So if I have to talk about, so that was agility, and I have described the 3 parameters for agility. Now, if I have to talk about machine learning, and if you look at any machine learning tool, and I mentioned Azure as a workbench, it gives these minimum steps. And they are, you formulate the problem. This is where you interact with the stakeholders and you talk to them, not just forming a problem that is only a technical problem. Then you deal with data processing. Then you build your descriptive, predictive, prescriptive model, categorization, classification. Then you train the model, then you test, and validation can come in between depending on how big is your data. Then you do prediction or provide an answer, descriptive. That's all machine learning. Now, all of this is what we do with a tool, but there is a much bigger circle over here. That is what I'm talking about, which includes agility and which includes process modeling. So typical machine learning process: data pre-processing, feature extraction, testing, training, validation, learned model. So it has learned from the feedback and starts making prediction. And what we do is we create a bigger wrapper around it with agility, enterprise architecture, and process models. So I mentioned process models. What do I mean by process models? So at a very basic, simplistic level, it is a flow chart. So here is my existing flow chart. If I automate it, the speed improves. Therefore, I have shown it slightly shrink. But if I optimize that flow chart, I am actually going to start questioning whether I really need activity B. And with AI ML models, many activities become redundant. And then I talk about A and B and A3 and A4 and the collaboration between these processes. So in a very simple manner, the key takeaway when you are doing AI and ML in business, in real life, is don't start with ML. Don't start with the statistical models. Start with the key stakeholder and create a process map like a flow chart. There is more to process mapping than flow charting, but that's the very basic before you start formulating the solution or the problem around the data and the technical solution. And there will be some challenges, and these are challenges that you should consider before you start the project. High volume data, where is it stored? What is the security and privacy of that data? Machine learning algorithm, which algorithm? There are at least 30 stock standard algorithms that are built in tools. Even humble Excel will provide you with some algorithms, which ones to use. How to provide training to your model? Is it supervised, or are we throwing data to our model saying, now go and find out some themes, and then making some predictions and enabling decisions, including training and change of mindset. So this particular one is very interesting, and ethically correct decisions may not happen if biases are slipping into data. For example, if the data is biased to say that anyone over 50, the majority of data over the age of 50, Indian background male person sitting in the USA is likely to have a heart attack, which is a terrible thing to say. But if the data is showing that, then the prediction will be that. And then the insurance company is likely to refuse insurance to me or charge me more, which are both could be considered unethical. Same with gender bias, male, female data comes in and you have a bad prediction, which is not ethically correct. So those are some interesting things, and data doesn't care because it is correlation and not causation. Now, finally, I have given some case studies to my students at another university in India, and right now they are working on these 6, and hopefully they will come up with some wonderful projects, presentations, health, agriculture, education, banking, environment, and production, manufacturing. This is just as an aside. So what are my key points in today's talk? Business is not interested in data science per se, but only in the value that they derive from data. You need to engage business. You need to produce iterative incremental approach to developing the solution, and you need to create process maps to make it more valuable. Here are some references if you are interested, and I want to thank you all. And here are my email addresses, and of course, you're welcome to connect with me on LinkedIn. Many students from MET have done so in the past. And also, once again, thank you to Rashmi ma'am, thank you to Ashok Bansal sir, and all the wonderful faculty and staff and students. I'm going to stop sharing, and we will take some questions if you have some. Thank you.
Anybody please raise questions or do some discussion?
Good morning, sir. कैसे हैं आप? How are you, sir?
Oh, Madhulita madam, yes, very very good. I am very good. मैं बहुत ही अच्छा हूँ. सिडनी में ऑस्ट्रेलिया में बैठा हूँ.
With family, sir.
फैमिली से 2 साल के बाद मुलाकात हो रही है.
I know, sir.
But there are people who have been in worse situation. Although I had COVID, I had no symptoms. Of course, I have maintained a good, healthy lifestyle. But it was an experience, and it delayed my flying twice. But now I am here. Thank you.
Okay, sir. Thank you, sir, for accepting the invite. It has been a long time you are associated with us.
I am. देखिए ना यहाँ पे in my home office, I'm carrying a beautiful certificate. शायद ठीक से ना भी दिखे because of Zoom. ये MET University. It says MET University honorary professor. How proud I am of that.
Thank you, sir. Thank you, sir.
Anyone else have any question? Any students?
Yes, sir. Thank you for your enlightening words, sir. It was a pleasure to listen to you give insights about artificial intelligence and business optimization approaches to combining the data analytics models with process models. We all feel privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new ideas to broaden their knowledge for expanding growth in the field of artificial intelligence. I believe your words have set new levels of expectation that our students aspire for. On behalf of MET University, Uttar Pradesh, I would like to extend my warm gratitude. Knowing how busy you are, we appreciate the time you took to impart us with your valuable knowledge. We are highly thankful to have you with, sir. Thank you so much, sir.
Thank you from my side as well. I also see Garima ma'am has logged in. So thank you, Garima ji. It's always nice. You have been interacting with us.
Thank you so much, sir.
My pleasure.
Spending valuable.
No, it's always a joy to come to India, even if it is a virtual visit. And please tell Dr. Bansal sir that I'm remembering him. All right. Okay,
Yes, sir,
I'll take your leave.
Sure,
Thank
sir.
you,
Thank
everyone.
you so much.
Yeah, my pleasure. Bye. Namaste
Thank you
to
so much,
all. And students are welcome to connect with me on LinkedIn. I'm the only Bhuvan Unhelkar available. And we'll see you next year, hopefully face to face.
Yes, sir, definitely. Thank you so much.
Bye.
Yes, sir. Now I'm going to call Professor Katina Michael. Good morning to all the dignitaries, professors, and the participants present today. On behalf of MET University Uttar Pradesh Department of Computer Science and Engineering, MET School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for keynote address of Conference 2022, the 12th International Conference on Cloud Computing, Data Science and Engineering. Even though we would have liked to invite you to our campus and have the keynote session in person, current world scenarios impede us with from all the doing so. Luckily, we are grateful to have the opportunity to keep keynote session in a virtual mode so that our students can reap the seeds from the knowledge gathered in this session. Now, I am profusely elated to take the opportunity to invite our honorable speaker, Professor Katina Michael. Ma'am is a professor in School for the Future of Innovation in Society and School of Computing and Augmenting Intelligence at Arizona University. Ma'am has contributed diligently in the field of emerging technologies and is a woman of distinct vision. Ma'am, you are an idol of knowledge, experience, and inspiration to many in the domain of research, as you have written 6 books, 500-page reference volumes, and more than 200 peer-reviewed research papers, with so much on board. Ma'am, you hardly need any introduction, having done guest editor of 14 special issues, including the proceedings of the IEEE Computer, IEEE Robotics and the Automation Magazine, IEEE Potentials, Journal of Location-Based Services, Computer Communications, Electronic Commerce Research. Ma'am was the editor-in-chief of IEEE Technology and Society magazine from 2012 to 2017 and has been the senior editor for IEEE Consumer Electronics magazine since 2015. Ma'am has contributed emerging technologies with her technical acumen and distinguished work. We would like you to invite on the platform to share a few words with us. Ma'am, please share your few words with us.
I just wanted to say a very big thank you for the invitation from Amity. Thank you to all the people preparing the conference organizers for working tirelessly and looking after all the authors. It's an honor to be here with you all. I'll pass back to you, Dr. Gandhi. Thank you. You would like me to begin, Dr. Gandhi?
Yes, ma'am. Kindly proceed.
Of course, of course. So, friends, today we will be talking about cloud computing data breaches in the news media, disclosure of personal and sensitive data. And the first thing I want to do is acknowledge that this keynote was directly the outcome of research conducted with Dr. David Kolevsky of the University of Wollongong, together with myself, Dr. Robert Abbas, and Dr. Mark Freeman of the University of Wollongong. The research occurred over a 7 to 8 year period, and today you see a summary of that written in a full paper that was accepted by the conference, but unfortunately couldn't make it into the proceedings given some difficulty with payment. So I would like to proceed by saying that cloud computing debates have really been captured in the news media, in the general population, as they absorb the various kinds of news that is leaked out based on breaches in cloud computing. And where else would consumers find out about breaches if it wasn't in the popular media? Surely consumers and end users of cloud computing are not aware of these peer-reviewed articles, nor are they aware even of trade journals publications, but they are very much aware of newspapers that they pick up to read. And the way that information leaks out to the general public is exactly the focus of the contribution of this paper. What happens when cloud computing data breaches occur in the information technology field? Do consumers even know that they're using cloud computing? What happens to personally identifiable information? Again, are consumers aware that PII actually go missing, or even worse than that, are sold on the black market? What happens when biometrics or passwords are stolen through a cloud computing data breach? And today we will be using 3 case studies to investigate this: the 2011 Sony PlayStation Network data breach, the 2014 eBay Incorporated data breach, and again, the Yahoo Inc. 2014 data breach. Now, important to note is that many of these companies, all you have to do is look up on Wikipedia to see how much and how many data breaches they have suffered. And unfortunately, the trend continues to increase in frequency. Data breaches are here to stay, and companies are at a loss to some degree on how to broach these data breaches or to block them from occurring, thus incurring brand damage. The more we hear of these big companies having had their systems penetrated, the less confidence we have as consumers to actually use platforms which use cloud computing services. But at the same time, the complexity in the value chain is one that we have to pay some respect to. Knowing how these cloud computing services actually work, the stakeholders that are involved, the multiple stakeholders, the enmeshed entanglements of these relationships to offer cloud computing services. Now we have cloud of everything and anything types of services. On the last count, somebody had said that were about 172 different services being delivered by cloud computing organizations. But knowing where the penetration occurred and why it occurred is a mystery to many of the members investigating, both in the legal sense, even within the organizations, those who are tasked with security, and even beyond that, definitely consumers are at a loss to understand why continually we have these hacks that occur or weak security physical requirements and why we continually see these penetrations. Later on in the talk, we'll have a discussion about this. We'll put forward some recommendations and a conclusion. But first to the literature review. Let's talk about the cloud computing value chain that I began to reference a moment ago. It is very important that we start to consider that value chains are very important in investigating data breaches. It's the dynamics and the interactions between key stakeholders. And as I reported with Kalevsky back in 2015, there are operational and non-operational stakeholders within the cloud computing value chain. In fact, we had identified different stakeholder types with Dr. Roba Abbas back in 2012. But who are the stakeholders that are directly involved in cloud computing service provisioning, and who are the non-operational stakeholders, and why does that matter? Why does it matter when we look at cloud computing or emerging technologies in general that we use a socio-technical approach for our investigation? Surely it is the interaction, this bi-directional feedback loop that we are investigating, and sometimes the weakest link, of course, may well be the one that we most do not suspect as being the weakest link, but that is where the breach may occur, and very much unaware the consumers are until they are notified via some digital service, whereby it's email or some kind of letter. They are told that a data breach occurred at a time in future history. It doesn't get back to the consumer very quickly, or the user, the end user. They are informed sometime down the track. So what is a cloud computing data breach? Well, let's think about it. Traditionally, we believe that data breaches involve security breaches which lead to the disclosure, access, or acquisition of information. So the hacker actually is attempting to garner some data that they may be able to use on the black market or the dark web. To define it, a data breach is when information is stolen or misappropriated, that term misappropriated. And according to many scholars, data breaches are a result of unauthorized access to private and sensitive information. And usually it is information of the end users, not so much the service provider. It's intentionally malicious. It's a hack. It may well be an accidental disclosure or publication. It may be an insider job. It may be because of lost or stolen computers or media that find their way into the wrong hands. And it may well be malfunctioning systems that have not had patches of security measures. But whatever it is, data goes missing. And as we said, usually it is end user disclosure. So hackers target a cloud provider or customer's weakest link to penetrate a cloud service. For example, employees are targeted through social engineering attacks in many situations, and social engineering attacks are not really attacks on physical infrastructure. They are more duping individuals to provide credentials that will lure hackers and grant them access into a particular security zone. So as we go through, we will be talking about socio-technical considerations, and we can point to why data breaches are important when we look at landmark data breach cases. And everyone points back to the 2005 TJX case study, which is one of the most infamous early case studies, with 45 million end users disclosing credit and debit card information data. We then can look at more recent hacks. A seminal hack here is the 2015 Anthem healthcare hack, where the victim of a data breach impacted 80 million end users. Again, you see these numbers increasing over time. And the breach disclosed names, email addresses, mail addresses, social security numbers, and healthcare information. And that healthcare information is what is considered in most jurisdictions as being sensitive and especially private. We can also point to Equifax data breaches in the 100 million plus. And what we find is that organizations are susceptible to attack. And what we further exacerbates is that the identity theft issues come about. So the research contribution of this paper in full length was that we used news media to investigate evidence, or to find evidence that would give us some kind of insight into how long it took until a data breach reached the end user in terms of being told about a breach that occurred and information that went missing. We do have previous contributions to the literature. We can point to Cross, Parker, and Sansom that examined the 2015 Ashley Madison case, which made front page news after 37 million subscribers. Details went missing. And they used media for discourse analysis on the controversial data breach. And they made use of the Factiva news media database. Factiva is an online database that aggregates and stores news media. And they used specific search terms to go and specifically look at the 2015 Ashley Madison case. We used these types of peer-reviewed papers to actually say, well, we've got a case here to use the news media. In fact, what was important is that we used the same approach that was valid. And then what we did is we used the three cases to frame our investigation. So we used the unit of analysis as the actual data breach case. We also provided search criteria using words like privacy, security, the breach, and the case study name. And we chose three case studies, as was noted: the Sony data breach, the eBay data breach, and also finally the Yahoo Inc. data breach. We used newspapers like the Australian Financial Review, the New York Times, the Wall Street Journal, the Washington Post, and a number of other well-regarded publications and newspaper outlets. In terms of our analysis, we used the Factiva database and a number of other sources to garner back the news articles and the media articles that were reporting on the data breaches. And through a process of a timeline, we began to piece what happened day by day and hour by hour. To give you an example, in the Sony PlayStation Network data breach of 2011, we find that on April 27, 2011, Sony highlighted that certain players' account information, including names, birth dates, email addresses, and login information, was compromised. The very next day, Sony warned the end users should be on alert for fraudulent activity on their credit cards. And about a day after that, Sony determined there was a difference in timing between when the company identified an intrusion to when it learned what users' data was actually compromised. A few days after that, April 30, Sony said that the data breach resulted in the loss of names, addresses, and possibly credit card numbers associated with 77 million accounts. On May the 2nd, Sony asked all users to change their passwords. It literally took them about a week to notify consumers and to tell them what had occurred. We see this repeated again and again. There is a lag between the time that it took for individual end users to be notified that their data had been breached or compromised or possibly disclosed by unauthorized access. And what we have is almost a very interesting comparative case between Sony, eBay, and Yahoo. Time and time again, there is a lag and people are not notified by what is going on there. So if we look for a moment on the discussion, the main points to take away from these case studies, if we compare these case studies together, we see that the same kinds of things take place, but to different levels of severity. Either people's names, mail addresses, and other personal identifiable information is stolen, or that includes also financial data and health data. Over time, what we see is that the attacks are after more and more attractive information, such as passwords and biometrics. Often people reuse the same passwords, and the cloud computing data breach is not the main issue at that point, but the end user's security online throughout all of the platforms that they use online. The other thing we know about biometrics is that once the biometric is stolen, it can't be recovered, and we can't change our fingerprints, we can't change our voice or facial image. And so these then become commodities or commodified on the dark web and sold again. In terms of data breach milestones and stakeholder engagement, what we require is more and more engagement by stakeholders so that people become less and less vulnerable. This includes internal employee training, not to be sitting ducks when hackers come to town with social engineering techniques. We need to inform customers and end users that they shouldn't click on emails that may cause phishing attacks or may open them up to further disclosure. We should also look at the consequences of cloud computing data breaches and know, for instance, that unfortunately the stakes are high but unprovable at this point. It is very difficult to claim the kinds of benefits and costs that come from cloud computing after a hack. How much does it cost the end user, for example, to have their PII stolen or on-sold onto the black market? The jury is still out on this, and it is very hard to claim undue stress, anxiety over having to change your credit card numbers, anxiety over your emails and kinds of phishing attacks and social engineering attacks that you might be privy to. In terms of future research, this will be a burgeoning research area where we have increasing numbers of cloud computing data breaches occur because we have more and more cloud computing services being offered to the community at large. And so if this is here to stay, what do we do? One of the things we propose is that cloud computing service providers and their customers are able to communicate faster and engage their end users and constituents faster. If people have some level of speed with regards to the requirement to change their personal details, there is the potential that they may not be affected by the attack, especially if it's a changing of passwords. Many people have stipulated that we need to get with the times and increase our biometric authentication and do away with passwords as a means for access to platforms or services. And again, using sensitive information as a way to log on and protect oneself in these new emerging technologies is arguably the wrong way to go about doing things, because what we're trying to do is broach further PII being stolen and that which is high at stakes, which is biometrics, for example. So finally, what we are trying to do is minimize the losses to the end user. We would like to see more organizations and service providers take responsibility for the data breaches, not just claim, oh, well, this is what usually happens in industry and we will be subject to security breaches. Bad is us, we've now rectified the security issue. How can we go further than that? So in closing, I'd like to thank Terry Bookman Again, Dr. Robert Abbas, Dr. Mark Freeman, and of course, the lead writer, Dr. David Kolevsky. And I hope that's given you a good overview of using news media sources to actually understand what happens during a data breach and to investigate the roles and responsibilities and accountability for various actors in the cloud computing value chain. Thank you.
Students and participants, you may ask some questions. It's a very lively session for knowledgeable session with the cloud computing, with the data breaches, as we have plenty of data, because nowadays byte dancing is going on. Everything is dealing with a byte and we have to dance on the bytes.
And all online. We are living during times of COVID, unfortunately, and a lot of us are checking in and checking out, Dr. Gandhi, as you say. And what about the COVID location stamp data? The data that determines the time and place we have frequented, both in shopping malls, for instance, or when we pick up our children at school. So Dr. Rashmi, very important what you are saying. There is a proliferation of this data on the cloud, and it is becoming more and more sensitive as we now rely on this backup for various applications, from health to finance and different things.
Okay, thank you, ma'am, for your enlightening words. It was a pleasure to listen to you give insights about the cloud computing data breaches in new media, disclosure of personal and sensitive data. We feel privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new ideas to broaden their knowledge for expanding growth in the field of data breaches. I believe your words have set new levels of expectation that our students aspire for. On behalf of MIT University, Uttar Pradesh, I would like to extend my warm gratitude. Knowing how busy you are, we appreciate the time you took to impart us with your valuable knowledge. We are highly thankful, grateful to have you with us, ma'am. Thank you so much, ma'am.
Thank you, and have the brilliant rest of conference, everyone. Thanks very much.
Thank you, ma'am. So now I would like to invite our next speaker. Please wait a while for him.
Hello, can you hear me?
Yes, sir, you are clearly audible. Very good morning, sir. Very good morning. Just wait a while.
Ma'am, can I make the session live or should I wait?
Yes. Yes, sir.
Okay.
You can make it live. Good morning to all the dignitaries, professors, and the participants present today. On behalf of MIT University, Uttar Pradesh, Department of Computer Science and Engineering, MIT School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for keynote address for Confluence 2022, 12th International Conference on Cloud Computing, Data Science and Engineering. Even though we would have liked to invite you to our campus and have the keynote session in person, current world scenarios impede us from doing so. Luckily, we are grateful to have the opportunity to keep keynote session in virtual mode so that our students can reap the seeds from the knowledge gathered in this session. Now, I'm previously elated to take the opportunity to invite our honorable speaker, Professor T.B. Vijay Kumar. He is a professor in Jawaharlal Nehru University, New Delhi, India. Sir has contributed diligently more than 80 research papers in international journals and conferences. Sir is a man of distinct vision. Sir, you are an idol of knowledge, experience, and inspiration to many in the domain of databases, data warehousing, data mining, machine learning, nature-inspired algorithms, big data, and analytics. With so much on board, sir, you hardly need any introduction. Having honored with the designation of ACM Senior Member by the Association of Computing Machinery, ACM, in 2012, and with the designation of IEEE Senior Member by the Institute of Electrical and Electronics Engineers in 2017. Sir has contributed as editor, session chair, guest editor for the international journals and delivered keynotes with his technical acumen and distinguished work. Sir, we invite you on the platform to share a few words with us. Kindly start, sir.
Can you hear me now?
Yes, sir, you are clearly audible.
Okay.
But you are
So,
not visible. If possible, make your camera on.
No, I am having this network problem, but okay. Let me talk on today because I was asked by Professor Abhay Bansal.
sir, sorry to interrupt you, sir. Can you make it full screen slideshow view?
Let me see. Wait. Okay. Okay. So is it clear now?
Yes, sir. Thank you, sir.
Okay. So I was asked by Abhay Bansal. So I would just deliver a talk on challenges and opportunities in AI and data science. I happen to be a professor and dean in School of Computer Science, concurrent faculty in School of Engineering, concurrent faculty in Special Center for Disaster Research. So I actually work on the application of AI in different areas. Disaster is one of such area, and then I'm also in concurrent faculty in Special Center for E-Learning. I'm also associate faculty with School of Computational and Integrative Sciences, which is mainly focused on computational biology. That is another area where I focus, and associate faculty with Atal Bihari Vajpayee School of Management and Entrepreneurship, because my background happens to be operational research, so I contribute there as well because I work on optimization problems. So. I will just have a very brief from the Indian perspective. I will talk about the challenges and opportunities associated with AI. So before I start AI, let me talk about the very important word that is big data today. Because the core of any AI technique is the data itself. And now this data has become huge as compared to the data earlier. Big data is something not buzzword. It's not a buzzword, but it is something that has evolved. The data has evolved over a period of time because of the advent of new technologies which could capture, generate such data. Big data refers to a collection of data sets so large and complex it is impossible to process them with the usual database tools. So when do you start calling a data big? When the existing tools, technologies, techniques are no more applicable to it. That means it has become more complex because of its the humongous nature of it, and there are other parameters like the weight, the speed at it is getting generated, and the heterogeneity that is prevalent within such data. So due to its size and associated numbers, big data is hard to capture, store, search, share, analyze, and visualize. So because the data has become complex due to various factors, so the existing tools and technologies fails to access such data, capture such data, store such data, analyze such data, and visualize such data. So this becomes a challenge. So we are aware of V's. There are many V's, but mainly focuses on four V's of big data, which happens to be volume, velocity, variety, and veracity. So volume comes from the aspect that data is at rest, but it is huge. It has grown in size. Velocity comes with the data which is getting at generating at a rapid speed. We don't store all data. Sometimes some data has no relevance after a particular amount of time, though it has relevant in a particular window of time. So in that case, while the data is getting generated, we analyze the data and send the results back to the user. So that is the velocity aspect where data is getting generated through these sensor devices, IoTs, and other devices. Then we have something called variety because of the heterogeneous nature of data that is prevalent on the web. Today we talk about the audio, video, image, text. They're all data of different kind and heterogeneous in nature. So handling such heterogeneity amongst data itself is a very challenging task. And last and but not the least, the most important aspect happens to be the veracity, because the amount of data that is available today is huge. And definitely, when there is huge amount of data, some may be authentic, some may not be, some may be reliable, some may not be. In that case, you have to look for data that is more authentic, more reliable, because so that your analysis are more authentic and more reliable. If you consider all the data together and don't take into consideration the veracity, the trustworthiness aspect into consideration, then you may land up analyzing and your analysis may be may totally go wrong. So the veracity is very important. So you need to associate trust with each and every data that is available so that you can apply. So next. Over a period of time, things have changed. There was an old model which talks about few companies are generating data and all others were consumers of data. So that has changed totally now, because today, because of these smart devices, everybody is calling smart devices that are being fitted with various equipments across, whether they are to do with day-to-day activities or in industries or any other place. Now the model has totally changed. The new model is all of us are generating data and all of us are consuming it. So things have changed. There is a paradigm shift now. We are all generating data and we are all consumers of data as well, because we are all carrying smart devices. We are all surrounded by these smart devices. So we are actually generating this data as well. At the same time, we are consuming it. So now what has happened is that harnessing big data, the transformation has taken place over the database research that has gone over a period of time. We started with online transaction processing when we talked about databases. We moved to analytical processing when we talked about data warehousing, because data warehousing had to take into consideration the past archival or the historical data. Now we are moving ahead. We are now moving towards something called real-time analytical processing, where the time factor is very important. Now the situation has become more time sensitive. Now today it's not all about getting correct answer to query, but correct answer within a stipulated time. Even if you get a correct answer, if it crosses the stipulated time, it is considered to be a failure. So that is what the things have changed over a period of time. Now, the ultimate goal is what? The ultimate goal is to find wisdom from data. Now, the tree usually stopped at knowledge, but knowledge is of no use unless you know how to apply it, how to make it into action, how to put it into action. So you had data which is raw in nature. You wanted to organize it so that it can be analyzed. So you had information which happens to be the processed, organized data. Then from information, you inferred something. Information is a meaningful data. So you inferred something very useful out of the information. That is what is called knowledge. Now, once you have inferred something very useful out of the information, it has to put into action. And that is what wisdom is. Always, always the knowledge may not, you have to validate the knowledge. You cannot say that your knowledge is correct. You have to validate it. So you have, in order to validate the knowledge, you have to put the knowledge into action. And when you put the knowledge into action, then only you can understand whether the knowledge is validated, is correct. And if it is put into action, actually it gets utilized. So the actionable knowledge is what is called wisdom. So ultimate goal of any analytics that goes around or anything in data science or is to find wisdom from data. Because you're not merely going to need knowledge, but you have to know how to apply that knowledge to gain the return of investment we call ROIs that needs to be arrived at from knowledge. Now, what is data science then? So data science is an industry field that uses scientific process algorithms and systems to extract knowledge and insights from data in various forms. It can be both structured, unstructured, similar to something called data mining. So data science is a concept that unifies various fields. It unifies statistics, data analysis, machine learning, and the related methods. It employs theories from various fields. Again, people from mathematics background, people from statistics background, people from information science background, and people from computer science background. It's a combination of all. So all people are, very useful when it comes to data science. The Turing Award winner Jim Gray imagined data science as the fourth paradigm of science. It started with empirical, then we went to theoretical, then we went to computation, and now it has become more data-driven. That's why I started with big data. The data is very important when you talk about artificial intelligence or data science. and asserted that everything about science is changing because of the impact of information technology and the data deluge. As I said, because of the advent of technology, now the data you are able to capture such a huge amount of data at a rapid speed, and at the same time, which is heterogeneous. So it's a technology that has led to such advancements in terms of data capturing, storing, analyzing, visualizing. But then it has become also a challenge because we don't have existing tools and technologies which are no more can do this task. So you need to look forward to something which can perform this task, and that too in real time. We are not talking about just performing a task, but we are talking about performing a task in real time. So when you talk about data science stages, we talk about data acquisition, data preparation, data mining and modeling, visualization and action, and model recomputation. So what do you mean by data acquisition? It's all about extracting data from multiple data sources, integrating and transforming data into homogeneous formats. Because in multiple data sources, when you try to have, they're all independently designed data sources. So when you try to extract data from these independently designed sources, they are going to be heterogeneous in some way or the other. They may have certain conflicts. You need to resolve them, make it more homogeneous, then only you can actually analyze such data. And then loading this transformed data, which is more homogeneous in nature, into a data warehouse, something, a big repository, a central repository, which stores such data for analysis. Then you have preparation. It handles missing and so when you have these values, whenever you submit a form on an internet or something, so you have certain fields associated with star and some fields have no star. So in the fields with associated, that is a mandatory value you need to fill. Whereas the case when their field is no star, in that case, you need to, then when you submit the form, what happens? So the null values are substituted for them. But how do you handle these null values? Because null values are very difficult to handle. So you talk about data cleaning. Then, when you collect data, every field, you may find that the field, because it is integrated, it is field data. So you may find that every field has a different range of values. Some may be between 0 to 10, some may be between 0 to 100, some may be between 0 to 1000. In that case, the higher range values may have more influence on the analysis. So in order to ensure that all of them have equal impact on analysis, you put them into the same range. So you have various methods doing so, like normalization, standardization, and then you need to move from categorical to numerical or numerical to categorical. Then there are handling outliers, can be used for fraud detection. Sometimes outliers are very important. Outliers are deviation from the norm. So every day you use a credit card, the way you use a credit card is known to the bank because that is how the thing. Suddenly, when you start using a credit card and with more frequency in a day, suddenly the bank realizes that you usually did not do it in the past. So it is an outlier. It's like the bank feels that it might be a fraud. Similarly, when you try to use your credit card abroad without telling the bank that you're going abroad, and suddenly the bank realizes how come this credit card has been used abroad. Again, it appears to be an indicator of frauds. So handling outliers is one. Then data integrity. And as I said, veracity happens to be the most important feature of data. So accuracy and reliability of data is very, very important. Because unless you pick the right data for analysis, your analysis can go haphazardly. So you need to first associate trust with these data, and the one which has having trust beyond a threshold, you use it for analysis. Then data reduction. All data may not be required. All features in the data may not be required. In that case, you need to find relevant features out of data. There are various techniques where the feature selection or extraction techniques can be used to reduce the dimensionality of data. Sometimes large number of features may make it much more computationally impossible, sometimes computationally infeasible to solve such problems. In that case, you need to reduce the dimensions of data. So there are techniques, as I said, feature selection extraction techniques may be adopted to reduce the number of features required for data. Then you have something called data mining and modeling. So it's a process of semi-automating and analyzing large patterns. You do analysis, you find what it may show, what it is there in the data. But sometimes what you find is you start with a perception, and whatever you perceive when you find in data, absolutely fine. It is nothing unusual about it. It is obvious. But when you sometimes what you do not perceive and suddenly you find it in data, that is what is mining. about data. For example, there's a famous problem of beer and diaper, where while trying to understand the transactions, they found that amongst all transactions that were there, which people already perceived beforehand, they found that beer and diaper were bought together in part of most of the transactions. Suddenly they understood that when they try to think about it, they can never perceive that beer and diaper would have had any relation. And then they found that it had relation because it is shown in the data. So there were many assumptions, many interpretations came out. Young couples on a long weekend drive, when they go on a weekend drive, they bring beer and have diaper for the child. Or they are watching football matches, they have beer, take beer and have diapers for the child. So many interpretations came. So when you talk about mining is all about finding something valid because they exist in data, novel, because it is non-obvious. If whatever is obvious is not mining, whatever is non-obvious is mining. It's useful. Definitely, if it is non-obvious, because you don't have a strategy for it. Now you see that it is non-obvious and you find it in data. Now it is useful because you can have a strategy. And it is understandable. Only when you understand, interpret it, then only you can put into action. That is, humans should be able to interpret the. Then you have the visualization and action. As I said, it's all about wisdom, not knowledge. Maybe mining and modeling will give you knowledge, but you need to put that knowledge into action. And that is what the ultimate goal is, to find wisdom from data. The results of modeling are presented in a meaningful manner, interpreted using various visualization tools for decision making. The decisions arrived at are put into action for its applicability in the real world. And that is what is more important. You have to put the knowledge into action so that these actions are actually applied and used in the real world. And then, as we know that model recomputation is equally important because models are based on data and data keeps on evolving. It keeps on changing. The trends of data keeps changing. So the model has to evolve itself with the changing trends in data. So data or characteristics of data changes over time and the accuracy of the model deteriorates. The model needs to be recomputed or updated periodically to cater to new data produced since the present model was recomputed. So model recomputation results in better accuracy. And that is what is all about model recomputation, because you need to keep evolving the model with respect to the changing trends in the data. So when you say, is big data the same as data science? No, they are same, but not exactly the same. Maybe not. Data science can be done on small data sets. And not everything using big data would necessarily be called data science. Definitely, there is a considerable overlap between the two. Now, is big data the same? So data science looks to create models that capture the underlying patterns of complex systems and codify these models into working applications. Whereas big data looks to collect and manage large amount of various data sets to serve large-scale web applications and vast sensor networks. Data science and big data can be summarized in one statement: collecting does not mean discovery. But when you talk about data science, you talk about analytics. So we talked about what are the different types of analytics. Usually people do analytics, but they do not understand how you go about doing analytics. So you start with a descriptive analytics. You start with a set of techniques for reviewing and examining the data sets to understand the data and analysis business performance. So you look for what has happened first. Then the second is, after descriptive, you do diagnostic analytics. It's a set of techniques to determine the reason of it. So why a problem has occurred. So you look for what has occurred, then you look for why it has occurred. Then after that, you do predictive analytics, a set of techniques that analyze current and historical data to predict the future. What is likely to happen next? That is what is predictive analytics. Then you talk about prescriptive analytics. So a set of techniques for computationally developing and analyzing alternatives that can become course of action. So what are the alternate solutions you can have? And finally, you talk about decisive analytics. It's a set of techniques for visualizing information, recommending courses of action amongst a set of alternatives. So you have identified alternatives. Now you identify which is the best amongst them. So what is the best solution for the problem? So you usually start with descriptive, what has happened, then diagnostic, why a problem has occurred, then predictive, what is the most likely to happen next, then prescriptive, what are the alternate solutions, and then decisive, what is the best solution. That is how you move around. So for all these analytics, somewhere on the line, artificial intelligence comes into picture. AI refers to the ability of machines to perform cognitive tasks like thinking, perceiving, learning, problem solving, and decision making. So it's all. Now, People were under the assumption in 90s that they're going to make machines that are going to behave like humans. What they did was they overestimated the potential of AI, but however, they underestimated the potential of human brain. And that forced them to realize that, it is not going to be just sooner to have machines that are going to imitate humans. That's why they were able to categorize AI into weak AI and strong AI. Whatever machines you come across today are based on simulation, whether it is a chatbot or any other thing. So it is weak AI. And what you aspire to have is the strong AI, which has actual thinking with consciousness, which a human possesses. Similarly, they talked about narrow AI. Whatever solutions you have in AI today are morely single task-based solutions. And then when it comes to what they desire to have is something called general AI, where you talk about multiple tasks as the human do. Human has the ability to perform multiple tasks. And that is where the term super intelligence came from. It's a combination of general and strong AI, where you're looking for machines that not only performs multiple tasks, but can think like a human. It has consciousness while thinking. And that is what is a super intelligent machine. And that is what AI community is aspiring to have, but it is not going to be sooner. And Stephen Hawking has said once that the day AI succeeds, that is the end of humanity. Because AI machines becomes like human, machines have high computational power. And suddenly you will realize that, there's a very funny this thing is, you can have today you see animals in zoo, you may land up seeing humans in zoo, and the AI succeeds. So that may also happen if AI is not used in the correct manner. But again, if machines become intelligent, you cannot stop machines behave like humans. It's so difficult for humans to survive. So Stephen Hawking had this statement made. So then you have one branch of AI, which happens to be machine learning. Machine learning is the application of artificial intelligence that provides systems the ability to learn and improve from experience without explicitly programming. You had, if you have talked about programming, you've been for a program, you give input and you give a program, you get an output. But when you talk about machine learning, you give input and output and you get a program. And that is the program is something which is still based on the learning from input and output. The primary goal of machine learning is to allow computers to learn automatically without human intervention or assistance and adjust actions accordingly. And the machine learning has been categorized in three: it's supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, we talk about data which is labeled. We talk about classes. So can apply what has learned in the past to new data using labeled examples to predict future events. So you have supervised learning where you are already labeled data. For example, somebody who's applying for a credit card, the bank already has labeled the past customers as good and bad. So they have all information which they are going to ask you. Along with that, they have a label which they have already given to the customers as good or bad. So when you apply for a credit card, you are actually and a model, and they have made a model learn out of those labels. And when you apply for a credit card, your information is fed into that model, and the model predicts whether you are going to be good or you're going to be bad. In case you are good, you get a credit card. In case you are bad, you don't get a credit card. So that is what the supervised learning is all about. It is supervised by the labels that are already being given. So examples in the supervised learning is regression and classification. It depends upon the output being numerical or categorical. So you talk about regression or you talk about classification. Then you have something called unsupervised learning. And when you unsupervised means you don't have labels. So it's like, creating classes of people. That is what is unsupervised. Like, when COVID came, people wanted to make hotspots. So they wanted to find out the patients and try to find that these are the hotspots because their maximum number of patients are here. So that is based on distancing. Distance may have used to form these hotspots or clusters. So clusters so unsupervised learning is all about when you do not have information about the labels, but somehow based on certain measures, whether it is similarity measure or distance measure, you compute the distance or similarity between points. And based on the similarity, similar points become part of one cluster and dissimilar part of different clusters. So you have techniques like clustering and association rule mining that comes under this study. There's something called reinforcement learning. So it is based on software agents that take action in an environment in order to maximize the notion of cumulative record. It's like playing a video game, and suddenly you put action, you lose. So you learn from that failure, and then next time you put. So you keep exploring, you keep hit and trial method, you keep learning the game, and you get reward points or penalties. So that is how you learn the game. So it's a method that allows machine software agents to automatically determine the ideal behavior within a specific context in order to maximize performance. It's a simple reward feedback is required for the agent to learn which action is best. This is known as reinforcement signal. And that is, that is how you talk about learning when you talk about the reinforcement. It's like learning from trial and error. You try, it's error, then you learn something better. So that's why when you play a game, you keep improving your score. And that is how you go about it. Then you have certain applications of AI, whether it is finding the shortest route by visiting all relevant cities, it's a traveling salesman problem. It can be autonomous planning and scheduling of tasks. It can be beating Kasparov in a chess match. You had these expert systems in the form of deep blue machines. You have steering a driverless class. You have the understanding a language. It can be a natural language processing area. Robotic assistant in surgery, and today it is very much used today, in robotic assistance, and monitoring trade into stock market to see if the insider trade is going on. So among these applications, I would like to focus the Indian perspective on the 5 different applications of AI. Indian Niti Aayog has come out with 5 focus areas of AI in the context of India. It talks about application of AI in healthcare can help address issues of high barriers to access healthcare facilities, particularly in rural areas that suffer sorry for this thing, just have a so it is like, this can be achieved through implementing use cases such as AI-driven diagnostics, personalized treatment, early identification of potential pandemics, or imaging diagnostics, among others. This is one focus area which Niti Aayog has focused on. The other focus area happens to be agriculture. The agriculture and rice sector still account for 50% of the workforce in India. It also has the potential address to challenges such as degradation of land, reduction in soil fertility, lack of assured irrigation, dropping water tables, overuse and misuse of pesticides and fertilizers. So AI can help in soil health monitoring and restoration. It can talk about improvement in crop yield through real-time advisory. You can take a picture of a crop and you can just send it using a smart mobile to the system. And suddenly you get a remedy what you should do so that the crop does not get spoiled or you identify a crop disease. So it can be advanced detection of pest attacks, prediction of crop prices, supply demand information. Other area is education and skilling. AI can potentially solve for quality and access issues observed in Indian education sector. Challenges is low retention rates, poor learning outcomes, multi-grade and multi-level classrooms, lack of interactive pedagogy, large teacher vacancies, poor teaching training, low adoption of existing technologies. The potential use cases might be augmenting and enhancing the learning experience through personalized learning. And that is why today, every student is not alike. Every student has different skills of learning, different speed of learning. So now AI focuses on the speed, how you can ensure that you are able to impart knowledge to everybody who may have heterogeneity in terms of learning, in terms of the capacity of learning. So predicting a need for student intervention to reduce dropouts, and that is another very important. How do you find out which student is likely to drop out in future or which student is likely to do? Even you can find out what is going to be the likely performance of a student after 1 year. And if it is poor, then you can find remedial actions so that it does not become poor. So customized professional development courses for teachers and automated rationalization of teachers. The proportionate utilization of teachers. Sometimes in India, people have found that, the distribution of teachers is not uniform. Some places it is more than required. Some places it is very less than required. So proper distribution also, it's a distribution problem. So AI can be of great help in this as well. Then you have these smart cities and infrastructure. Integration of AI in newly developed smart cities and infrastructure could also help meet the demands of rapidly urbanizing population, providing them with enhanced quality. Is it like smart parks and public facilities, smart homes, crowd management, traffic control to reduce congestion, intelligent safety system, and cyber attacks by identifying the vulnerabilities? So AI can be of great help here as well. Then you have this smart mobility and transportation. Forms the backbone of modern economy due to their linkages to other sectors and importance in both domestic and international side. Issues, congestion and road accidents, high number of traffic deaths, lack of public transportation infrastructure. So potential uses can be semi-autonomous features such as driver assist. It can be predictive engine monitoring and maintenance. It can be improved traffic management and community-based parking. So that can be of great use. But all these things are part of today, what goes around the world is the Industry 4 revolution. We had industry, the first revolution being the steam engines, then electricity, then internet, and now we are talking about the AI revolution. And definitely all countries across the world are looking forward to this. They are investing huge amount of AI so that they can have more productivity within them. So that's why a lot of investments is getting into AI. Every country is looking forward to it. And that is why as a country, we should always have these center of AI excellence, which has boundaries, which does not restrict to computer science. It has its application, whether it's in linguistics, law, biology, social science, humanities, all areas it covers. So it has its own importance across. So that's why it is always advised by various institutions to have this Center for AI Excellence, because this will act as a transdisciplinary field where it can help support other fields of education, whether it falls in science, whether it falls in social science, or whether it falls in humanities. So what we aspire to have is we should not miss the AI revolution, because this is going to be most important for the future development and the economy of a country. So thank you. Thank you very much. Thank you.
Thank you, sir. Any queries? Students, researchers, anybody else who wants to ask something from the sir? Sir has given very fruitful session. Okay. So thank you, sir, for your enlightening words. It was a pleasure to listen to you give insights about challenges and the opportunities in artificial intelligence and data science. We feel privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new ideas to take the admission in engineering or in different sciences, how they will work in BTech AI, BTech data sciences. So this session will broaden their knowledge for expanding growth in the field of education and skilling, for the good research and how to validate that research in the field of agriculture, smart cities. So I believe your words have set new levels of expectation that our students aspire for. On behalf of MIT University, Uttar Pradesh, I would like to extend my warm gratitude. Knowing how busy you are, we appreciate the time you took to impart us with your valuable knowledge. We are highly grateful to have you with us, sir. Thank you so much, sir.
Thank you very much. Thank you, and take care and be safe. Thank you.
You also take care, please, sir.
So can I leave now?
Anybody else wants to ask something? Okay, thank you, sir. You may leave now.
Good morning. Harimohan sir, how are you?
I'm fine, ma'am. How are you?
I'm good,
How are you
sir.
doing?
Very happy to see you here.
Yeah, same here, ma'am. Same here.
Yes, sir.
It's
You remain very...
morning, 5 o'clock in the morning in Britain.
Okay.
I generally don't get up such a,
yeah.
morning.
Okay.
Yeah.
So how is temperature there? Weather is too cold?
Yeah, it's -2 degree right now. And
yes.
I'm using room heater.
Okay.
And yeah, so it's -2 degree here in Britain at the moment. But temperature will increase. It will reach to 4 to 5 degree by 1 o'clock or 2 o'clock in the afternoon. Yeah. Okay, sir. How's everything going on at your end?
Yes, sir. It's going very fine.
Yeah.
Yes, our student will going to submit the thesis very soon.
Yeah, that's really good.
Yes.
Yeah.
Okay, sir. Usha ma'am, please proceed.
So can we start?
Yes, let me share my screen first. Then I will start. So before starting, I just want to know, can you see my screen?
Yes, it's visible. Just put it on a slideshow mode.
Yeah.
With brief introduction, we will start.
Yes. All right. So I think I'm audible, number one.
Yes, you are audible, sir.
And you can see the slides.
Slides also. Yes, sir. So just
okay, that's
let
really
me introduce and then we will start with the.
All right, that's perfect.
Okay. So good morning to all the dignitaries, professors, and participants present today. On behalf of MIT University, Uttar Pradesh, Department of Computer Science and Engineering, MIT School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for keynote address for Confluence 2022, 12th International Conference on Cloud Computing, Data Science and Engineering. Even though we would have liked to invite you to our campus and have the keynote session in person, current world scenarios impede us from doing so. Luckily, we are grateful to have the opportunity to keep keynote session in a virtual mode so that our students can reap the seeds from the knowledge gathered in this session. Today, I am profusely elated to take the opportunity to invite our honorable speaker, Professor Dr. Hari Mohan Pandey. Dr. Pandey is a professor in Department of Computer Science, Edge Hill University, UK. Sir has contributed diligently in the field of artificial intelligence, soft computing, and machine learning, and is a man of distinct vision. Professor Pandey is an author of various books in various fields of computer science. He has published over 50 scientific papers in reputed journals and conferences, served as session chair, leading guest editor, and delivered keynotes. He has been given the prestigious award, the Global Award for Best Computer Science Faculty of the Year 2015, Award for completing Indo-US Project Gentle, awarded a certificate of exceptionalism from Prime Minister of India and award for developing innovative teaching and learning models for higher education. So you are an idol of knowledge, experience, and inspiration to many in the domain of artificial intelligence, soft computing, and machine learning. With so much on board, sir, you hardly need any introduction. So now we would like to invite you on the platform to share a few words with us. Please, sir, over to you.
Thank you very much for introducing myself to the audience. Actually, I'm not like outsider. I'm the part of a MIT University because I'm alumni also. I did my PhD from a MIT University, number one. Secondly, I worked for the Department of Computer Science for 4 years. I spent my 4 years and the basic ground of my career was developed at MIT University and in the Department of Computer Science. So it is a great honor for me for this keynote talk. And as far as my keynote talk is concerned, you can see the title, which is enlisted in my first slide, and it is meta-heuristic algorithm for cluster head selection in wireless sensor network. So all in all, my focus will be on genetic algorithm because genetic algorithm is one of the meta-heuristic algorithm, and I will explain how genetic algorithm will fit for solving cluster head selection problem for wireless sensor network. She has already introduced myself. I'm Dr. Hari Mohan Pandey from the Department of Computer Science at Yale University. I have given my email ID, official and personal email ID, which you can write down, because if you want to discuss anything after my keynote, then you can drop me email. So I will start my presentation with the outline. So I have given a quick outline with a few bullet points. So in the beginning, I will start with introduction and motivation. Then I will present the summary of the state of the art of research which was done in the field of finding cluster head selection for wireless sensor network. Then I will give the objectives of this particular session Then I will talk about the framework which has been developed for cluster head selection in a wireless sensor network. And then I will discuss results and the outcome of the results. And finally, I will give concluding remark of my presentation. So I will start with the first bullet point, which is introduction and motivation. And as far as introduction and motivation is concerned, I have given a diagram, and you can see there are 3 clusters given in this diagram. This is cluster number 1, this is cluster number 2, and this one is cluster number 3. And the red nodes, the central node is the cluster head, and the blue node are the member of the cluster 1 and cluster 2 and cluster 3. So the purpose of identifying the cluster is, if all the node of the cluster will communicate with the sink to transmit the information, then it will be difficult to schedule the information, so that each cluster appoints a cluster head. All the nodes present in the cluster will share the information to the cluster head, and then this cluster head is responsible to pass that information to the sink. And if any information will come to the sink, then sink will send the information back to the cluster, and then cluster will send that information to any particular member node present in the cluster. So this is the basic idea of clustering and in wireless sensor network. So as far as wireless sensor network is concerned, the basic idea of wireless sensor network WSN is, it is a self-organized network. So you can see this is self-organized network. And if you want to configure or create a wireless sensor network, you have to distribute the nodes like these nodes randomly in an environment. Sensor nodes basically given to transmit or receive the information for the user, and it has wide range of application. Wireless sensor network has wide range of application, which I have enlisted. Some of the application area are listed here, so that you can understand the importance of wireless sensor network. It has application in military operations, agriculture, disaster management, healthcare, and industrial purpose. But there are some challenges, and that is the reason we need a new system to solve or to address the challenges. So here I will explain briefly what are the different challenges still exist in wireless sensor network, and then the demand of the new system. So as far as challenges are concerned, you can see I have summarized the challenge in 3 bullet points. If you are placing the node randomly in an environment may be of any type. If it is in a smooth area, then there is no problem. You can, if the node is not working or the energy has lost, you can go and you can replace the node. But if the node is placed in a harsh environment, then it is very difficult to reach to that particular region to replace the node. After sometimes, if you are using nodes, each node works based on some energy. So after some time, the energy level of the node get lost. So we call that node as dead node, and replacing that dead node is very, very important to get the good functioning from the wireless sensor network. Some constraints will be there, and we need to address those constraints in order to run the wireless sensor network. So considering these challenges, there is a need of a new system. So I have given why new system is required and what we will do in order to develop a new system. So here I'm going to discuss an energy efficient communication using sensor network to increase the lifetime of the wireless sensor network. So how, when I say increasing the lifetime or extending the lifetime of the wireless sensor network, it means that in a wireless network, if I'm using a cluster, suppose this shaded node is my cluster head, and this is one of the clusters. So what I'm going to do, I'm going to minimize the energy use in the system. So if node will use less energy, then the lifetime of the network will increase or extend. Here I have given the basic idea of clustering in a wireless sensor network. So what researchers generally do as far as cluster head selection is concerned, they basically minimize the energy consumption in a sensor node so that the lifetime of a wireless sensor network can be extended or increased. So this is, I already explained. So there is a cluster, nodes are distributed in a network. So one of all these nodes are considered as member node of a cluster. Suppose this is C1 is my cluster 1, and in cluster 1 I have placed some nodes. What I want to do, I want to select one of the node. At present I am not knowing this is my cluster head or this is my cluster head or any other node is my cluster head. I would like to select any node as a cluster head so that I can, this cluster head will be used to communicate with the SIP. This is the basic idea, which is given in the second point, and rest of the node will be treated as cluster member. So the problem here is, in a multi-hop communication, data transmission, I already briefed about this. Data transmission needs cluster head to play a bridge between member node of a cluster and SIP to transmit the information. Same thing is explained. I already briefed these points. So we need a cluster head. And this problem, identifying a cluster head among the different nodes present in a cluster, is a NP hard problem. And for finding the solution of NP hard problem, we need a good algorithm or good system. Why it is NP hard problem? This problem statement is given. Selection of Q number of optimal cluster head. We would like to, suppose I have n number of nodes. So here the total number of nodes are represented as T. So I have T number of nodes. Out of T number of nodes, I would like to select a cluster head Q, sensor node in the network, and this is QCT will be treated as cluster head for any particular cluster out of T number of nodes. So this is the problem statement, and it is NP hard problem, and meta-heuristic algorithm plays a significant role in order to solve NP hard problem. So as I said right in the beginning, I'm going to apply meta-heuristic algorithm, and as far as meta-heuristic algorithm is concerned, I am focused on my presentation is focused on genetic algorithm. So in the next slide, I have given the basic idea of simple genetic algorithm. And in order to explain the basics of simple genetic algorithm, I have given a flowchart. So this flowchart says that if you want to apply a genetic algorithm, the basic idea is you need to first generate population, then evaluate the fitness of the population, apply recombination operator like crossover operator, mutation operator for reproduction, then apply selection, check the termination criteria. If it meets, then terminate the process. If not, then apply for again apply selection which of population which will participate in reproduction process, and this process will keep on running until the termination criteria will meet. The idea of genetic algorithm is proposed by is based on Darwin's principle, which is survival of the fittest. That is the reason this is survival selection, and this is selection for new iteration or new generation. So if a population will survive, then only the population will participate in the new iteration. It works based on 3 operations: crossover operation, mutation operation, and selection operation. And it is suitable for NP hard problem and cluster head selection in a wireless sensor network. For minimization problem is NP hard problem. So that is the reason I have applied this. In the next slide, I have given the summary of the state of the art work done in order to select a cluster head in a wireless sensor network. So I have given a quick summary in a tabulated form, which you can refer. I will share the link of my paper where I have given all these details, the details of the state of the art where genetic algorithm is applied. Now I will quickly cover the key objectives of this presentation. So the first key objective is I'm going to talk about a new algorithm which is based on genetic algorithm for selection of cluster head, and in short I call this algorithm as NCO-GA, novel cluster head selection applying GA. And then the second key objective is it is not just proposing a new algorithm or implementing an algorithm. We need to check the algorithm's behavior, and in order to check the behavior and performance, I have compared NCO-GA with other state-of-the-art methods. And the algorithm which I'm going to discuss in this keynote session is one of the novel approach and first ever work for cluster head selection in a heterogeneous wireless sensor network. So here the term heterogeneous, let me explain what is the meaning of heterogeneous. Here I'm going to use energy, and heterogeneous means energy is classified in 3 categories: normal energy, advanced category, and super category. Normal, advanced, and super category. That is the reason I call it heterogeneous wireless sensor network. And the overall aim of applying genetic algorithm is to minimize the energy loss of any particular node or the cluster node. In the next slide, I will explain the basic structure or framework of my algorithm for wireless sensor network. So I have divided the framework in 4 phases. These are the 4 phases, like heterogeneous energy model of NCO-GA, working of the algorithm, operational steps of this algorithm, and network framework. As the time is just 30 minutes, so I'm going to focus on the second bullet point, that is I will demonstrate, I will show the steps which I have applied for finding the cluster heads in a wireless sensor network. In the next 3 slides, I will just quickly show, and if I have given a link, because the next 3 slides is for energy model, which I'm not going to cover in this particular session, but you can refer. So I have given the terminology which has been used for energy model. This slide is for heterogeneous energy model. This is the link. I have given the link which you can refer to understand heterogeneous energy model, because it needs additional time, which I do not want to give for this particular session. And you can refer this paper or this paper to understand how the energy model will work. These 2 are my papers. And as I said, I will focus on the working of my algorithm. So as I explained earlier, for the basic structure or organization of genetic algorithm, we need to first initialize the population. So as far as population is concerned, I have given chromosome structuring. So as for chromosome structuring, I have used nodes, cluster nodes, to represent a set of chromosomes. And in order to represent the node, I have used binary representation. And in binary representation, we use 0 and 1. So what is the meaning of 0 and what is the meaning of 1 is explained here. So cluster head is represented by 1, and other node or normal node are represented by 0. Because I'm placing, this is my search space, I'm placing the nodes randomly in the search space, and without knowing which node is my cluster head. So my algorithm will assign random values to each node, like 1, 0, 0, 0, 1, 1, 0, like that. And then I will consider this binary number as my chromosome. Then the next step of applying genetic algorithm for wireless sensor network for cluster head selection is initialization. So I have created some set of nodes, chromosome, but I am not going to use all. So suppose this is my chromosome structure in a binary format. So I'm going to pick some portion, like out of 50, suppose this is 250 size chromosomes. So out of 250, I selected, let's say 140. And this selection is done by applying some mathematical and statistical approach so that I can say the algorithm is developed in a robust environment. So the selection is random after applying some statistical methods. Here, the novelty which is involved with this particular algorithm is the fitness function. This fitness function is given to evaluate the fitness value of chromosome. And in order to evaluate the fitness value of chromosome, I have considered 6 parameters which are listed here. So I considered residual energy of a node, initial energy of a node, distance, sink is here, cluster heads or nodes are here. So what is the distance? This distance is considered as one of the criteria to evaluate the fitness function value. Number of neighboring nodes, suppose I assume that this is randomly, this node has been assigned 1, other node has value 0. So number of neighboring nodes is one of the criteria. Communication mode decider, which type of communication mode is there, and what is the load given to a particular node to transmit the information from the particular cluster to the sink. So these 6 parameters are considered to create the fitness function value. I will explain the equation of each parameter one by one. So here I have given, this is my first parameter. I already briefed you why I selected residual energy, because this for implementation of my algorithm for wireless sensor network for cluster head selection, I have used a heterogeneous wireless sensor network where energy is classified in 3 categories: super, advanced, and normal. So here this parameter is given to deal with energy. Then what is the initial energy value when I'm applying my algorithm for any particular wireless sensor network to select the cluster head? Then before applying, I will check what is the initial energy value of the node. For that, this is the equation. Then I have given distance from sink to the cluster. So distance is another criteria, and this third parameter is for finding the distance. Next parameter is number of neighbor nodes of a cluster. So total number of neighbors node present in a cluster will be evaluated using this equation. Then communication mode decider, CMD, will be evaluated by equation number 14. And this is for load balancing. And then I have used this equation, equation number 16, to integrate all the parameters. So this is the main equation for which I have applied for determining the fitness function value of any particular node. So you can see parameter 1, then parameter 2, third parameter, fourth parameter, fifth parameter, and sixth parameter. In order to understand why I selected these parameters, you can refer the paper which I showed you earlier. All the details are given in that paper, but I'm not giving a detailed idea of all these parameters because it will take time, and I just want to focus on the working of. So these 2 papers I showed you. So you can, if you want to refer the way I selected the parameters, let me show you. Yeah. I think I missed that slide. Yeah, it was somewhere here. So here, this is the link, and this is the paper. This is for the second link, and this is for the first and second link. Now I will move back to my fitness function value. Yeah, so I was here. So this is how I have evaluated the fitness function value of the nodes. And these values are nothing but the fractional values to balance the equation, and the sum of these fraction value will be equal to 1. And for selection, selection is one of the important operation in a genetic algorithm. For the selection, I have applied rank selection methods. So what will happen? Each chromosome will be assigned some value based on the fitness function, and I will rank the chromosome. Suppose this is fitness 1, fitness value 2, fitness value 3. So based on the value, fitness function value, I will rank them, and then the fitness value, if the fitness value is minimum for any particular chromosome, then the chromosome will get selected and for the next iteration or for the next generation. As far as crossover operator is concerned, I have applied single point cut crossover, and the example is given here. So this is my chromosome represented in binary form. Here 1 represents cluster head, 0 represents normal node. A cut is applied here, and this is before and this is after the cut. So you can see a single point cut crossover is applied. Why crossover and mutation operators are applied? Because if we will not apply recombination operator, then there will not be any change in the chromosome. And if there will not be any change in the chromosome structure, then there will not be any change in the fitness function value. So in order to introduce the variation among the population and to find out fitness function value, we need to apply crossover operator as an exploratory operator. The next operator which is applied in this algorithm is mutation operation. Bit inversion mutation operation is applied. I have given one example. So before mutation, after mutation. So here you can see bit inversion is applied. So 1 is converted to 0, 0 is converted to 1. So bit inversion mutation operation is applied. This is one of the simplest mutation operation where we can just revert the bit. Now I have given the flow chart for the algorithm and COGA. So randomly nodes are distributed in a heterogeneous environment. Then we will evaluate the fitness value. For fitness value, I have given the equation where I have summarized or have considered all 6 parameters. Applying this equation, F is equal to the same equation was explained earlier. Then some stopping criteria is set. For the stopping criteria, I have selected maximum number of generation. If the algorithm will reach to maximum number of generation, then it will stop. And the second criteria which was set for termination was maximum number of generation. Initially, the number of generation will be 0 and will keep on running. In each iteration, I will increase. Suppose first generation is 0, then in next generation 0 plus 1, that is 1. So the same thing is explained here. Generation is equal to generation plus 1. Then I have applied selection based on the fitness function value. I will rank the chromosome, and then if their fitness value is less, I will select the chromosome to participate in the next generation. Then I have applied crossover operator, considering the crossover rate. PC represents crossover rate, and as we know, the standard value, this is the probability, so it will lie between 0 to 1. I have selected 0.5 as my crossover rate, and this 0.5 is I got this 0.5 after applying statistical approach to develop a robust experimental environment. And then I have applied mutation operation. Here PM represents mutation. As far as mutation value is concerned, it should always be lesser than the crossover value. In my experiment, I selected 0.3. Again, this value is selected based on some statistical approach which was applied for the algorithm. And then parent selection, and then identifying the fitness, and we will keep on repeating this process until we will reach to the termination criteria, which is presented here. In the next few slides, I'm going to cover the simulation and results and analysis. So for the implementation of the algorithm, which was explained just now, I have selected several parameters. As I mentioned right in the beginning, these values are not random. In order to find out these values, massive experiments, extensive experiments have been conducted. some statistical approach was applied. The statistical approach which was applied for finding the suitable value for the algorithm is known as Togachi approach. Togachi with orthogonal approach. So I applied these two statistical methods to decide these values for these parameters in order to implement the algorithm. So I can say that the experiment or the implementation of NCOGA is conducted in a robust experimental environment. Now, what is the performance? So in order to measure the performance, I have considered some performance metrics. So all in all, I have considered these many parameter metrics: stability period, network longevity, number of dead nodes, throughput, network remaining energy. So these are the performance metrics which were considered to determine the performance of NCOGA. In the next slide, I have given the performance comparison against the state-of-the-art methods. So I compared the performance of the proposed algorithm against 3 most recent algorithms. I have given the name of the algorithm. So you can see the stability period is better than other algorithm. HND represents half node dead is also better, and network lifetime got increased as compared to other 3 algorithms. Now, as far as network lifetime is concerned, network lifetime is evaluated based on 2 criteria. First criteria is alive node versus rounds. So total number of round of communication against alive node. Then dead node versus the total number of round. So you can see the performance of my algorithm. Just a minute. News got started because it's my morning time actually now. Yeah, so here you can see the performance of the proposed algorithm is far better than other 3 algorithms. And when I consider dead nodes, again, number of dead nodes are very less as compared to other 3 algorithms. Now I consider this performance matrix. When it comes to remaining energy, again, you can see the performance of the proposed algorithm is better, because after some communication, some round of communication, still node has more energy as compared to other 3 algorithms. Now, the next performance matrix, throughput, you can see the throughput value is again higher for this algorithm as compared to other 3 algorithms. Now, percentage improvement of my algorithm against state-of-the-art algorithms are presented here. So you can see from this algorithm, 52.27 stability period got improved for this algorithm. This table represents the percentage improvement of the proposed algorithm against the state-of-the-art algorithm. And this result reveals that the NCOGA showed a significant improvement in the performance of the network. I have performed some statistical analysis also, and in order to perform statistical test, these are the hypotheses. So null hypothesis and alternative hypothesis. So initially I assumed that there is no change in the performance of all 4 algorithms, and alternative hypothesis says that there is change in the mean value of the algorithms. When I conducted descriptive statistics, the results which I got after descriptive statistics, it reveals that the performance of proposed algorithm is far better than other 3 algorithms. And in order to conduct this statistical test, total number of sample was 50. 50 samples were selected in order to conduct a statistical test. I applied ANOVA test, that is F test, and the result of F test clearly indicates that there is a significant difference in the performance. This results indicate that the null hypothesis failed. So alternative hypothesis, will be considered in this case, because the value of significance value of that is the p value is lesser than 0.5. I conducted a statistical test at 95% confidence interval. So what I did in order to understand which algorithm is showing the difference in the performance, I have applied homogeneity test to categorize or to make a group of algorithms. So you can see the performance of DCHGA was the worst, and the performance of the proposed algorithm is the best. And these two algorithms showed average performance. That is this and this. So I have categorized the performance based on by applying homogeneity test on the algorithms. Again, the sample size was 50. Then I created marginal plot for the algorithms. So you can see this point indicates the mean value for this algorithm. This point represents the mean value for this. Here you can see the mean value is higher than other three algorithms. So this results clearly indicates that the performance of NCUGA was better as compared to other three state-of-the-art algorithms. In the next slide, I will summarize. I will give the summary as a conclusion. So here you can see I have explained NCUGA, and the novelty with this algorithm is it uses 6 parameters: second parameter, third parameter, fourth parameter, fifth parameter, and sixth parameter. These 6 parameters to determine the fitness function value, which is new with NCUGA, and it has shown significant improvement as compared to the state-of-the-art algorithms. This result was already explained in the slide. And as far as future work is concerned, if anybody is interested, you can work on this. You can extend the algorithm for mobility network, like, and quality of service of the parameter. So mobility sync network can be considered, and then you can measure the quality of services. So that's all from my side. This is my contact number. Again, I have given here. And thank you very much. If you have any question, I will love to answer the question. Is there any question?
There are no questions, but student will definitely reach to you.
Yeah.
And, on the given mail ID.
Yeah. Okay.
Okay. So thank you very much, sir, for your enlightening words. It was a pleasure to listen to you give insight about the novel meta-heuristic algorithm for cluster head selection in wireless sensor networks. We feel privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new ideas to broaden their knowledge for expanding the growth in the field of wireless sensor networks and optimization of the WNS using novel meta-heuristic algorithms. I believe your words have set a new level of expectation that our students aspire for. On behalf of Amity University, Uttar Pradesh, I would like to extend my warm gratitude. Knowing how you are, we appreciate the time you took to impart us with valuable knowledge. We are highly grateful to have you with us. Thank you very much. Thank you.
Thank you so much. Thank you so much. So I'm leaving this session.
Okay. Thank you. Thank you very much, sir, once again.
All right.
So can we start with the next speaker? Vishal, sir.
I'm ready. No issue.
Okay, sir. So good morning to all the dignitaries, professors, and participants present today. On behalf of Amity University, Uttar Pradesh, Department of Computer Science and Engineering, Amity School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for keynote address for Confluence 2022 12th International Conference on Cloud Computing, Data Science and Engineering. Even though we would have liked to invite you to our campus and have a keynote session in person, current world scenarios impede us from doing so. Luckily, we are grateful to have the opportunity to keep keynote session in virtual mode so that our students can reap the seeds from knowledge gathered in this session. Today, I am profusely elated to take opportunity to invite our honorable speaker, Dr. Vishal Goyal. Dr. Goyal is a professor in Department of Computer Science, Punjabi University, Patiala, Punjab. His research areas are natural language processing, technology development for differently abled people, data analytics, AI, and machine learning. He is a NAC assessor and visited many colleges and universities for this purpose officially sent by NAC. He is a coordinator for Research Center for Technology Development for Differently Abled Persons established in his university. He is a deputy director of Center for E-Learning and Teaching Excellence. So has recently joined as a coordinator Punjabi Pedia Center and coordinator Punjabi Computer Help Center too. He is a member of various board of studies of various reputed state universities across India. He is a regular speaker in UGC HRD refresher and orientation courses conducted by UGC HRDC across India. He has been awarded with the Young Scientist Award in 2005 by Punjab Academy of Sciences. He has been awarded with a state award 2 times by Punjab government. He has into his credit 10 copyrighted softwares, 1 trademark and 2 patents. He has been recently sanctioned a project on corpus development for Kashmiri, Urdu, Dogri, Pashto, Dari, Balochi, Sindhu worth rupees 1.25 crore approximately by Government of India Ministry. He has about 80 research publications in various journals and conferences of national and international repute. He also has recorded 11 video lectures on DBMS at EMRC Patiala as a part of their MHRD project, which are uploaded on CEC website for open access. He was a PI of MOOC program on cyber laws available at Swayam portal, and this MOOC program has already been executed 2 times. He is a coordinator of NPTEL local chapter of Punjabi University, Patiala. He has regularly been interviewed by various TV channels and radio partners for their research on NLP and technology development for differently abled persons. He has been offered the honorary position of IT consultant at Maharaja Bhupinder Singh Punjab Sports University, Patiala. Sir has contributed diligently in the field of natural language processing, data analytics, AI, and machine learning, and is a man of distinct vision. Sir, you are an idol of knowledge, experience, and inspiration to many in the domain of natural language processing, data analytics, and AI. With so much on board, sir, you hardly need any introduction. So now we would like to invite you on the platform to share a few words with us. Please, sir, over to you.
Yeah, thank you very much, ma'am, for the nice introduction. I think I am very clearly audible.
Yes, sir, you are audible. Just...
Okay. So very good morning, Professor Abhay.
Yes, thank you for sparing your valuable time to be with us.
Thank
and
you.
I continuously look for your mentorship, guidance, your presence, any and every activity we do it at MIT School of Engineering and Technology. Thank you very much for your time.
No, anytime, sir. So can we start the talk?
Yeah, please.
Yes, please.
Oh, that's nice. So thank you very much for inviting me over here on the virtual conference. So today I'll be talking about plagiarism detection tool for Indian language documents with special focus on Punjabi and Hindi documents. So I guess most of the audience that is attached with us, they must have used Turnitin, they must have used Urkund, some might have used Authenticate, right, for finding the plagiarism out of the documents they are submitting for their research purposes. They need to submit as their PhD thesis or research papers. So if they are submitting in the English language, I don't think any major issue has been raised during finding the plagiarism. But if the document is in Hindi or Punjabi, So many of the researchers must have faced the issue that the plasm detection tool is not giving the correct results about the plasm. So there are simple reasons behind that, because the technology is not up to the mark, the repository is not up to the mark in the existing plasm detection tools. So looking at all the problems and the limitations of the existing plasm detection tools, so we had proposed one project to the Ministry of Electronics and Information Technology in the R&D in Electronics Group, Innovation and IPR Division, Government of India. And we were lucky enough to get the funding of 20 lakh rupees for the development of this project. So this is the administrative approval that I have shown you the screen that has been given to us by the ministry. So you can see the screen in which it has been shown that plasm detection software to check the thesis in Punjabi. So this will be a reality in coming days, because this is the news covered by the Tribune for Punjabi University Patiala. So I had the partner with me from DAV College Jalandhar, Dr. Rajiv Puri, who was the co-PA of this project, and we have executed this. And this is the first, I think, Punjabi detection tool that is working good for Indian languages. But we have primarily focused on Punjabi and Hindi only. So this is the news clipping of one news in which it has been mentioned that what are the punishments by the UGC if 10% similarity is found, there is no punishment.
So sorry to interrupt you. So your slides are not moving. So if you
it's not moving from my side, it's moving. Okay, let me
slideshow mode. Yes, now it's moving. Yes, so please put it on slideshow mode also. Thank you.
It is on slideshow mode. Okay, let me reshare. Okay, I'm just. Is it fine now?
Yes, sir, perfectly fine. Thank you so much.
Thank you. Sorry for the disturbance. So, okay, so this is the news that is published in the newspaper, in which you can see that what kind of levels of plasm are there. Level 0, if the similarity is up to 10%. So minor similarities, so there is no penalty. Level 1, similarities between 10% to 40%, it will be asked to submit the revised subscript within a stipulated time period, not exceeding 6 months. Similarities from above 40 to 60%, students shall be debarred from submitting a revised script for a period of 1 year. Level 3, similarities above 60%, registration for that program shall be cancelled. So you can see that UGC is very strict enough about the plasm. So even you can see the news at the bottom of this. UGC found 2 vice chancellors plagiarizing in past 3 years. So the action has already been taken on those vice chancellors. So once upon a time, the UGC had decided to go for the Turnitin software because its accuracy is more than the Urkund. Now its name has been changed to Original. So, I don't know what happened at the background, but now again, the Original has been taken as the official, plasm detection tool by the UGC, and it has been distributed among various universities to use. So this is a news a clip by the Punjab University Chandigarh, in which you can see the middle portion of this news, in which it has been mentioned that language departments should devise mechanism. So why they have mentioned it publicly? For the subjects of Hindi, Punjabi, Sanskrit and Urdu, where Turnitin originality report system does not function, these departments should devise their own mechanism to check the plasm. So it means that it has been accepted by the Punjab University Chandigarh that the plasm detection tool doesn't work for the languages. So then it is definitely it's a need of the hour that we should develop the plagiarism detection tool that is capable of working for the Indian language text. So when we have proposed the project, so these were the aims and the objectives what we have decided. First is the investigate the NLP techniques for plagiarism detection. Then use the plagiarism detection techniques for detecting plagiarism in Punjabi and Hindi text only for that purpose. Design a system with the modules capable of detecting the character sets, fonts used in input document and encode them in Unicode format. So what does it mean? Ma'am, how many audience are attached along with us through the Zoom meeting?
So there are students and other research scholars who are attached to.
Okay. Do they have the access to speak out?
No, sir. Sorry, sir. Actually, due to time, we have not.
Okay, fine. Yeah. So so here I would like to tell you about what you mean by Unicode, right? So first is what is Unicode? Unicode means that when you have written some text in Indian language, like if I talk about you have a text in Hindi or Punjabi. So way back, long time back, what we used to do is you go to some typist outside our institute, get our matter typed. But that matter is typed in their own fonts, like Kruti Dev or any proprietary Hindi font. So when you are taking that soft material along with you and try to open in your own system, sometimes it doesn't work. Why? Because you need to have that font installed on your system. If the font is not installed, you will be looking all the text in the form of junk characters. But it is not in the case of Unicode. If you have typed get your matter typed, or you have typed your matter in the Unicode encoding, so wherever you will take your matter, there is no need to install any specific font, and you will be able to see the correct Hindi typed or Punjabi typed or any Indian language typed matter properly. So Windows operating system, XP and above all have the Unicode fonts installed by default in their systems. If you open the MS Office, you will be able to see that Mangal font is there. That is Hindi Unicode. And if you look at Ravi, RAAVI, so this is the Punjabi Unicode font, right? So if our system works only on Unicode encodings, if you are submitting some document that are not in Unicode, so first you need to convert into the Unicode format. So we have developed the converter, font converter as well. So if you have some specific font text, so it will be able to convert into the Unicode encoding. So then is removing the stop words. So whenever we are whenever you are finding the plagiarism out of the text we are submitting, so there is no relevance of is, rm, ka, ke, ki, right? So these are the stop words, right? So we are removing all those stop words when we are processing the documents. Then is normalizing the text using the stemmer or lematizer. What do you mean by that? Stemmer and lematizer means like when if we are you have inflected words and there is a stem root associated with it. So we are bringing the input text on the root level. So we are removing all the inflected words and we are replacing with the stem, so that if the researcher has copied some material and played with that text by just replacing the word with the inflected word, so all will go away and we are matching with the stem document only. So our document is capable of finding the copy paste material, syntax and semantics plagiarism, word switch plagiarism, synonym used, all are taken care. So very short matches should be ignored, as the writing styles of two authors may match up to some extent. So our system has been designed in such a way that this tool can be extended for any of the languages, like it is work for Hindi and Punjabi, but the architecture is, if we are getting the language resources, we will be able to extend it for other languages too. So diversity in the Punjabi Hindi fonts, you will not believe that we have collected 250 fonts over here, right? And we have developed the font converter for it. So what are the challenges? First is we need to collect all the fonts. We have to find out the mappings in that fonts, and then we have to generate the font converter. Then is lack of Punjabi Hindi literature, right? So lack of Punjabi Hindi literature means, so matter is not available on the internet that is there for Hindi or Punjabi. So very less literature is available. So we have to make a big repository for Hindi and Punjabi documents. Selection of suitable discriminators that reflect the pleasant and non-coincidental similarity. So we have to do in the programming efficient Punjabi Hindi stammers. So stammers are not very good. So we need to develop the stammers from the, not I shouldn't say from the scratch, but we have to extend it to improve its accuracy. So a lot of ambiguities are in the languages. So we need to cope up with that also. So this is the screenshot of our software that we have developed. I will be giving the demo shortly. So this website is shodhmapak.co.in. And this image has already been trademarked, and the software is copyrighted too. So I will be showing you some of the results and then coming to the technical details. So this is, we have found, we have given some PDF document to Urkund, and you will see that it is giving 0% similarity. Why it is giving? You can see this type of text has been extracted by the Urkund. So if the text is not extracted properly, so results will no doubt be good. Then again, we have submitted one more document and it is giving 0%. Why? Because the results, they have already extracted the text in Punjabi, still results are 0. Then we have given another document, it is giving 9%. So this is how it has extracted the text. You can see it is a junk that has been extracted. So now I am comparing the results with my own Shodh Mapak. So the document were same. Urkund is giving 0% and Shodh Mapak is giving 32%. Another document was submitted, right? So it is 0% and it is 55%. Another is 0%, 89%. You can see the differences over here. Another document, it comes out to 0%, it comes out to 80%. So here it has been mentioned that we have taken the text from internet, right? Here, this is a paraphrase text. We have modified the text. We have paraphrased the text. It is giving 0%. Our system is giving it 40%. Then Punjabi text mixed thesis, right? 0%. It is giving 57%. So then it is, we have taken the text from the Shodh Ganga. So it is giving 1%. It is giving 100%. Next, this is how it has been extracted by the Urkund. So then we have again picked up from the Shodh Ganga, right? So it is giving us Shodh Mapak, it is giving us 100%, but it is giving 0%, right? So then we have processed Hindi document, right? Again, it is giving 0%, it comes out to be 35%. Then this is how it has been extracted by the Urkund. So you can see these triangle marks. Triangle marks means it is not able to process these documents. So difficulty. Why? Because it is not able to extract the text from the PDF file. Then we have picked some stories, Punjabi stories. So Shodh Mapak is giving us 99%. Then again, one more novel has been given. It gives us 100%. Then some Hindi text is given. It comes out to be 100%. They are scanned images. So these were some of the eye-opener things that I have shown you. Now, what we have used Tesseract OCR. I guess you people know about Tesseract OCR. So this is a PDF to text converter. So it has the support for Hindi and Punjabi. There was a problem of Sihari that we have resolved it. And secondly, we have used the Apache Solr, and I guess that in India, we have worked on this basically, right? So Apache Solr, it is for document indexing purposes. Then we have used Twitter Bootstrap, we have used PHP and Python, we have used JSON as well. From where we have collected the data, we have crawled the web. Google APIs has been used. Then we have used the OCR and data entry we have done manually. This is very interesting. We have a Punjabi Sahit Academy over here at Ludhiana. So their very old Punjabi theses are placed on the racks. My team used to go over there, click their images through their own mobile cameras, and they have collected 1 lakh pictures from there. They make a repository of the on the hard disks, and then we have digitized all these. So there are 300 theses, but we have digitized only 150 because other are the typewritten theses, and they are of the poor quality, and we were not able to do it, but our research is going on this one. You can see these images that are clicked. So this is the news that was telecast, published by the Tribune, that research work available at Punjabi Sahit Academy, Ludhiana, it was digitized. So approximately 100 theses were not in the readable conditions, and they are not. So this is the Google crawler that we have developed. If you put any keyword, so it will crawl it. Then what we have done is we have done font converter for Hindi, font converter for query documents, conversion into Unicode encoding, XML based character mapping, and Unicode modules for Punjabi and Hindi. So this is the screenshot of Punjabi ASCII to Unicode and Hindi ASCII to Unicode. Then we have removed the stop words. So this is the module for stop word remover, in which you are putting the input text over here. When you click on the process, it is removing all the stop words and giving you the text over here, result output over here. So this is the stammer that is used. These are the rules that are displayed over here, that how many times these rules are being used while processing it. And you can see over here that color coding has been used over here. So the color coding has also been mentioned, that if it is a brown, it is a named entity and it has not been stamped. If it is green, so these are the exceptions. Black, there is no change. So pink, so in this way it is done. Synonym replacement, I guess you people know about the WordNet. So there is a TDL consortium on the WordNet in the Dhanush. So you can just search the TDIL. So WordNet is available on that, and we have used that WordNet from there. Local repository has been developed, in which we have done automatic indexing and malware indexing. So we are finding the keyword corresponding to the document that has been submitted by our own as well, and the user is also submitting the keywords. So this is how the document indexing works in Apache Solr. So this is the snapshot of the Apache Solr. So we are using the approach of Ngram approach, and we are using the approach for document vector based approach as well. So this is how the Ngram works, in which we are putting the text and how many words you need to go for. So it is the Ngram 4-gram results are displayed over here. This is how the interface looks like, in which first is the job ID, another is for which language, Punjabi or Hindi, you have submitted the document. This is the title of the document you have submitted. So when you have submitted and when the processing has been completed. And when it is finished, so you can click on the green button to see the status. And if you click on the percentage, the full report will be generated to you. So this is how the report looks like. It is similar to the original report. We have tried to make it similar to the original. This is how you can just click on the percentage and you can get the details from where it has been taken. So this is how we can do the login. This is a user approval, how you can submit the job over here. These are the job results that you can see. These are the existing two results, like Urkund, how it displays it. So these are some of the snapshot of the Shodh Mapak, and you can see the Urkund results. We have used the Google crawler as well. We used Google Search API for getting the real-time results in our system, so that is required. Web crawler also used because we are searching from the net as well. And we have used the web scraping as well by downloading the thesis from the Shodh Ganga and putting it to our repository. So when we are OCRing it, results were not good. So we have developed one OCR corrector as well. Then we have already copyrighted this software, and trademark of name and the logo is also in process, and it is almost done. So we are thankful to the Punjab Digital Library as well. They have provided us with the 4 DVDs in which 324 books were there, but they were of no use because they were the handwritten books and we have not used it. But still, we are thankful that they have cooperated with us. So we are really thankful to the Punjabi University Library, from where we have downloaded the things. We have scanned the documents and put into our repository. So this is the detail of the repository, in which we have 3,895 PhD theses. For Punjabi, we have approximately 900. 2 MPhil theses, research papers has also been put into, and then so many books are there, so many magazines are there, and total is this like approximately 3,900 documents for Hindi and 2,352 documents for Punjabi. So these are the endorsement letters that were given by the Punjabi University Patiala after the validation of our tool. This is by the Guru Nanak Dev University, and this is by the Punjab University Chandigarh. So this is all about my work. Now I would like to give the demo if the time permits.
Yes,
If
sir.
the time,
Yes,
how,
sir.
oh, that's great. Is my screen clear? Visible?
Yes, sir, it's visible.
Yeah, so this is the homepage of my website, shodhmapak.co.in. So if I click on the login, so I can log in from here, right? And you can see a lot of options are there. So if I look at the my jobs, so whatever the jobs we have submitted, it is displayed over here. So this this has been completed. So if I click on this 3%, right? So it will show me the results, and the result that will be displayed will be approximately having the same format as we used to see in the original. Yeah, so you can see the screen over here, in which this is the result. This is the summary part, right? It is the result that has been displayed. And these are the documents from where the plasm has been found. These are the internet sources from where it has been found. So this is the detailed result that has been shown over here. You can click on this and it will display the document that has been submitted and what we have found. So this is the report that is there. So download option is also there, print option is also there. So we have a lot of other administrative options also. You can see over here. So repository is also there. You can see the list over here. If I talk about the Punjabi, you can see this is my repository in the Solar that we have put into, right? So I have a lot of tools that are there for this. So I have a stammer over here. If you put the text over here, and you can choose what level of stemming you want to do. You can choose the Punjabi, Hindi, English over here. So you can see the results will be really good. Similarly, we have the tools for converting the ASCII into Unicode. So this is the software. You can see we have a lot of fonts that has been put into it. You can select the font and convert into the Unicode, right? So similarly, stop word removal is there. So you can put the paragraph over here, choose the language, it will remove the stop words. Then you can see PDF reader. That is also very challenging task, because text we do not have any PDF readers, so we need to develop it, and that also took a large amount of time. OCR character is there. So this is OCR character. This is even keyword detection. So you put any text over here and you can find out the keyword. So this about the Shodh Mapak that I have done. I would like to show you one more very interesting project that we are working on, and it is funded by the ministry. This is related to the deaf and dumb people, and this is a machine translation project that we are working on. We are converting the English text into Indian Sign Language. This Indian Sign Language is for the deaf and dumb people. So this is we have logged into it. Oh, oops! I need to find out. Okay, so I think the email ID has been changed. I need to check. It will take time. So I think I should stop over here because I'm getting out of the time. So queries are welcome from your side.
The student will reach to you for any queries because here we have not allowed them to ask the question.
No issues, anytime.
So thank you very much for enlightening words, sir. It was a pleasure to listen to you to give insight about a plagiarism detection tool for Indian languages with a special focus on Punjabi and Hindi documents. We feel privileged to have your supervision backing us. Thank you. Your talk was particularly insightful at a time when students are considering new ideas to broaden their knowledge for expanding the growth in the field of natural language processing, especially for the Indian languages. I believe your words have set a new level of expectation that our students aspire for. On behalf of Amity University, Uttar Pradesh, I would like to extend my warm gratitude. Knowing how busy you are, we appreciate the time you took to impart us with your valuable knowledge. We are highly grateful to have you with us. Sir. Thank you very much. Thank you so much, sir.
Okay, thank you very much. So I'll take a break over here. Fine. Thank you.
Thank you, sir. Thank you very much.
Hello, good afternoon. Am I audible?
Yeah.
So good afternoon to all the dignitaries, professors, and participants present today. On behalf of Amity University, Uttar Pradesh, Department of Computer Science and Engineering, Amity School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for keynote address for Confluence 2022 12th International Conference on Cloud Computing, Data Science and Engineering. Even though we would have liked to invite you to our campus and have the keynote session in person, current world scenarios impede us from doing so. Luckily, we are grateful to have the opportunity to keep keynote session in a virtual mode so that our students can reap the seeds from the knowledge gathered in this session. Today, I'm profusely elated to take the opportunity to invite our honorable speaker, Mr. Nitish Vij. He is a director data analytics at artificial intelligence at Wipro Limited, Sydney, Australia, who has 2 decades rich experience in envisioning and delivering analytics lead transformation for large organizations. He graduated with a BTech from HPTI. He did his MTech in applied mathematics from Indian Institute of Technology, Delhi. He has worked with leading organizations across the globe and helped them in leveraging the latest technology innovations and trends to stay ahead of their competition through data-driven disruptions. He had worked with business leaders across domains to solve complex business challenges through data and analytics, having held the responsibility of managing P&L for delivering and accountability for business development. He has proven track record of managing customer relationships for growing business and managing the cost of deliveries worth multi-million dollars. So we invite you on the platform to share a few words with us. Nitish, sir?
Yeah, thank you, Anshul. Can you hear us? Hear me?
Yes, I can hear you, sir.
First of all, thank you so much for inviting me and giving me this opportunity to talk to you guys, including the esteemed faculty, guests, and the students. It's always heartwarming to be present at Amity campus and speak to you. I've been doing this for past many years, coming to your university, and it always gives me a pleasure to be there, and always feels like being at home and discussing with the generation next that is coming up. So very interestingly, the topic for today, which you guys have, can you see my screen?
Not yet, sir, not yet.
Can you see it now?
It's loading, sir. Yes, yes. Now it's visible, sir. Visible.
Perfect. So what I was saying is, I mean, it's always a pleasure working and talking, and today's topic being cloud computing, data science, and engineering. This is something that is very close to my heart, working on this topic for the last almost 2 decades in terms of the data, how we can, how the data is shaping the world. So what I tried to capture in today's thoughts, half an hour is extremely less time to cover such a large topic. So what I wanted to do is to entice the students about, not into the depth of how it has to be done, but what and how the world is getting changed. What are the practical use cases which we are seeing in industry, which are, changing the way we think, we work, we behave, or how the ecosystem is actually helping the businesses in generating more and more business, how it is helping the life of the people, how it is shaping the future, changing the lives. So just beginning from there, I mean, as I said, I'm not going to go into the technical details around how those algorithms are being developed, or what is the technology stacks behind it, what are the different offerings from the multi-cloud service providers, but as to how these applications have been changing the world, that's what I'm going to take it. And I'm more than happy to go and discuss in length about the details around how this works, but probably in the short half an hour that we have for this presentation, I'm going to take about what is happening around the world, how the AI, decision science, data science, machine learning is changing the world, and how the cloud computing is changing the way we solve the new problems. So I'm just reminiscent of my old days, going back 30 years, and I'm just looking at it, what I can think about it. And now I'm talking about when I was a teenager, living in a small town. I had to buy a shirt, and the best thing was ask your dad, "Hey dad, I want to have a shirt," and then he will take you to the small shop in the town and say, "Hey, Iqbal ji, show me a shirt. Give my munda a check shirt which he would like," and Iqbalji will come up with some 5, 7, 10, 20 odd designs, and then you pick them up. So that's how the generation Y teenager, when we were growing up in 80s, 90s, when that's how you did the shopping. And why did we pick up Iqbal and Sons? Why the check shirts were picked up? Why that shirt was specifically picked up? Because it was influenced by the peer, because that was the trend. That's what you wanted to look when you're with your friends. Now go forward, I come forward 30 years. My son is the same age. What if he has to buy, and interestingly, the same shirt? What he does is he gives me a call and says, "Hey, Papa, can you give me the T-pin you would have received, because there's a shirt that is being launched by Adidas or some big brand, and they want to they have done a pre-launch of it. I want to buy it. I have subscribed to it, and now I just have to give that T-pin." He has not gone to the shop, but he's buying the same shirt, but the experience has changed. So now if we look at it, where is he buying it? He's buying it online. He's buying it from Amazon. He's still buying it from the Adidas of the world. But if you look at it, what are the influencing choice for these millennial teenagers? They're influenced by the peers. And I'm just looking at the broad term. They are guided by the marketing. And whose Amazon probably would have given them, a precursor about that this is a cool shirt that is being worn by a Beyonce, or worn by someone who's more influential on the social media. So we are launching this shirt. They give a time frame, half an hour available, and you can pre-order it and you can buy it. Same shirt, same thing, but a different buying experience. Let's look at what the future holds for us, what we are looking for, how the things are going to be working into the future. The same shirt to be brought by somebody in, let's say 5 years down the lane, hanging in a metaverse, be it a sandbox or Meta or anything, and you are visiting a virtual showroom, which very much resembles 42nd Precinct in New York, and you're trying the different outfits digitally and then ordering it. And then you go with your friends, and mind you, it's all hanging virtually. You are not even wearing the shirt. The shirt that is going to be there in your avatar is almost a digital shirt or an outfit that would be, and it is the same shirt. In 80s, it was the same shirt. Now in the 2020s, it's the same shirt, and next 2025, it's going to be the same shirt. But what is it that is happening? Your buying pattern is changing. Now, depending upon what is influencing, you're still influenced by the peers. And very interestingly, if you look at it, the shirt is not to be worn by you in physical. This is something that you're going to be wearing in a virtual world, working with your, having a cool, good time with your friends, walking around on the virtual beaches or a virtual land, but getting the same experience as to what you see it as a reality. Now, the question is, what is that? How did you get hold of the same shirt, which was probably 80 years or 40 years back in fashion? Because it is something that your peers are wearing. Now it is something that is guided by the marketing. But more and most importantly, it is the data science that is actually giving you. How do you see when you are visiting in a meta world, somebody approaches you and shows you this shoe and asks you to buy it for your digital avatar for a $1? How did he know that you are there? How did he know that you have a preference for this shirt? How did he know that you will buy this for yourself in there? So those are the technical data points which all the marketing agencies, all these large organizations are actually picking it up. They are ready. They are looking for, where are you guys hanging in? They are looking for, where are you guys? What are you guys wearing? Who are you there with? What kind of shopping do you do? What kind of platforms are you using? And based on that, they'll try to look for your preference. And when you look at it, I mean, if you look at it, it's about millions of users getting those itemized, customized preferences on their preferred media at the time when they're about to click and when they're about to buy. That implies that there's some system that is big and big enough to have that kind of processing power. Now look at it. If you look at the Meta, Facebook, definitely they can have their own large, big systems. But what about the Adidas? Would they like to invest into the technology and create those forms? No, probably not. So if you look at it from that perspective, to do this mind-boggling data engineering that we need to process the kind of data within the real time, within the time frame when the customer is about to buy. So right time, right processing, right data, and the right offer. That's what is actually helping these organizations that sell that shirt to you. Now, if you look at it, I mean, I'll give you a simple example back again. If I remember going back to Amity, talking to a couple of guys in there, they were talking about going to, back to get to see, you got your parathas, chais, your snacks, your local tapariwala in there, who knows you by the name. But how many people does he know about? 30 people, 50 people, 100 people in a batch. He knows their preferences. Now, if you look at when we were growing up, and when in the 2000s, when we were growing up, there was this concept of the loyalty cards that came up. And then you will present the loyalty card to the store and they knew your preferences and they'll give you. If you look at how the Amazon does it today, they are looking at it, what kind of phones are you guys using? What kind of shopping does you do? So then processing all this. Now, rolling back into the point, if let's say Amity, I understand, is one of the melting pots for the cultures, Bollywood. I mean, a lot of movies stars being coming in there, promoting in there. So think about a scenario. You are again back into that metaverse with your friends, and there is a show of, let's say, Beyonce show which is there, or a Taylor Swift show which is there, and suddenly the crowd, or suddenly the number of subscription goes by some 100 times. What is going to happen? The servers are going to crash. Nobody's going to go back into it. So who supports the infrastructure? That's what you see it as, the infrastructure providers. That's where the cloud computing power comes into the play. Amazons of the world, Googles of the world, Azure, IBM, Oracle, Alibabas of the world. They provide the infrastructure that can be scaled on demand. So that's the power of the cloud, which is being harnessed to process the amount of data which is being used by these next generation I won't call it the marketing agencies, but the product companies, the organizations, to get the new customer experience into the picture. So the very recent study which is being done by the Gartner, and what they have published is that by 2025, the choice set for the customers, I mean, if you think about it, if you go to a store today, if you go to the Amazon today, there are hundreds and thousands of products. There are hundreds and thousands of merchandise SKUs which are there, and you're all confused which one to choose from. The same way, Amazon is also confused which one to show you. Flipkart is confused which is the best suited product which the customer will buy. So what Gartner says is by 30% purchase and preferences will be driven more by the personalized experience. No longer it is about how this shirt, this is a cotton shirt, this is the design. The personalized experience of how you would look like, what your peers talk about, and how many people are talking about this shirt, what is the craze about this shirt, what is the unique thing about this shirt, how does it fit you. The personalized experiences that can be drawn on any product will define the preference and purchase for a will define the preferences for the purchase for any particular product. So if you look at it, what are the different things where these organizations identify your preferences? We are talking about the connected technologies and computing systems. No longer it's an isolated system that is sitting in your house that you go and you are going to a local kirane wala and buying your daily needs. Rather, the purchase that you make on a Zomato or a Swiggy or any other platform, this is all being looked for every set of data that can be harnessed from it. We'll come to the next slide and we'll talk about what kind of data points that can be harnessed, which are visible to you and some of which are not visible to you at this point in time. So, and how do these organizations track your journeys continuously across these different platforms? So connected customer journeys, they play a very important role. You walk into a Geo showroom and you are looking for a product, but at the same time, when you come back into your store and you punch in your name and it is being captured that you were looking at an Apple phone and they're the same product and the same display, your preferences that were caught at your physical store are being displayed online. Similar way, when you are looking at your laptop and browsing a session and suddenly you move into a mobile device and you are actually looking at the same website, how does the same preferences or the same shopping cart or a list gets transferred from your product, from one product to another? That's the kind of a connected experience that which we are talking about. So that's the connected experience, connected system, which is being fueled and powered by the cloud computing is what is deriving, what is helping these organizations to form a customer knowledge platform, which is the most important aspect in today. When we say that data is the new oil, data is the new soil, data is the new lifeline, data is the new bloodline. But to process this massive amount of data, this customer knowledge platform, these are being hosted on the on these cloud data platforms, which can provide the on-demand scalability as and when required. Now coming to it, what we were talking about, how does it all things work? So when you are looking at invariably, when you are doing, you go to a showroom and you are buying a product, or you go to a Geo showroom and you're buying a phone in there. So what are the different things which they are actually capturing? Not just about the product which you want to buy, the different things. Your IP address, what location are you calling up from? That defines your demographics, that defines the preferences. What kind of appliances are you using? An iPhone or are you using a Samsung? That is there any question? I hear a background. So that defines what kind of priorities you have, what kind of purchase power you have. If you look at what kind of appliances you switch on from your Apple laptop, you move on onto your Apple phone, and then immediately your customer profile triggers that you are a fan of an Apple, not an Android fan. Similarly, when you're looking at what kind of phones, are you using a high-end Samsung S21, or are you using the Nokias or the Xiaomis of the world, or what that defines your preference in terms of your spend ability and what your peer group has been spending upon. Looking at it, what kind of wearable device, wearing a wearable device on your hand can give you how many steps you have counted, how many calories you have burned. It gives you all that information, but that gives the information to all these organizations to help you make your profile. They know that you have been using the profile, you have been working on your laptop for 12 hours a day, and you have been sedentary user because you have been sitting in one place, so they can offer you something that can make your lifestyle changes. So those are the personalized services which they will get based on the different data points which are being collected from the various touch points where you interact with these organizations. This could be the appliances that you are working on, or whether you have a connected air conditioner or Samsung one, whether it is a Carrier one, what kind of temperature that you have put it on, for how many hours your house that air conditioner is on, what kind of power usage, power bills you are having. That all helps these organizations make a 360-degree profile of you and help them identify what are your preferences and come with this. Now, that's about the data points from where all these data points can be collected. What are the touch points from where these all data points can be collected, where these are the sweet spots from where we can get all this information. But what happens next? Having that data and then making a meaningful information out of that data is the most important aspect of the whole thing. That's where your data engineering plays an important part. So the whole, if you look at it, the journey of the data to a meaningful information passes through a life cycle that is built on a platform which is to be hosted by an humongously large ecosystem of infrastructure which is hosted on the cloud, and that is what it relates to the theme of today's discussion: the cloud computing, the data engineering, and the data science. So if you look at it, acquiring this data in the real time, from the time when you actually make those steps to making that decision and giving you the feedback back into your system, or to give you that opportunity to buy, it is all a real-time process. For example, if you are walking down the mall, and if you walk past Apple store, and if you get a coupon, immediate coupon that talks about a 20% discount on Apple product if you buy it in the next 20 minutes. Think about a scenario that if this offer is given to you when you are 15 kilometers away from the Apple store, it won't be relevant. If you are already went past the Apple store, it won't be relevant. So when the offer has to be at the right time at a right place. But if you look at it, this is a hypothetical concept in a sense that we have been talking about, which has been made practical by how the data engineering aspect. Till 5 years back, we were struggling to get that real-time offer loaded based on your geolocation, so that any of the purchases can be made instantly and those offers can be more relevant. But in the last 5 years, if we look at the real-time streaming of the data from every device, millions of devices, looking at millions of customers' profiles, matching them to their geolocation in the real times and sending those offers, it is a no mean task. It needs a lot of computing and a lot of software engineering, both in terms of processing the data and finding the right preference for the customers to actually do it. So if you look at this, is kind of a technology architecture in a very high level, acquiring the data from these sources, processing the data, getting the data to come into the shape and form that can be analyzed by your customer intelligent platforms, which primarily leverages your descriptive machine learning, predictive machine learning, cognitive NLP, and a lot of statistical knowledge to create a customer knowledge graph which talks about your preferences, your spendability, your demographics, all the data points and how they are related to the different events that happens in your vicinity or that may impact you. And then getting those insights to based on those customer knowledge graphs at the right time, that will depend up that will trigger those decisions to buy the products. So this is the complete spectrum where you can say how the data from it, where it originates to how it gets consumed. That encompasses the data engineering and the decision science systems, data science systems. Now, coming to a few of the examples which we see on the daily basis in and around us, everybody is aware of, the Netflix, one of the most important platform, especially if you look at in the today's context when we have all these lockdowns, we can't go up. The viewership for the Netflix, Amazon Prime has gone above the roof. But have you noticed something very interesting in this? For the same product that I'm looking at, the same show that I'm looking at, depending upon what is my genre, the visual or the advertising for that product changes, that show changes. For example, I'm watching a Money Heist, I'll probably see a professor being chased by the police. But if somebody else is watching, probably he will see Helensky and his friend walking down depending upon what kind of a genre you are on. The same show, the same product, the same viewership, but what your genre, it is personalized, and that's how they are advertising you. And which is only possible by following what your experience is, what you are watching, what your demographics, what your preferences are, and then enticing you into the show. So that's a very classical example that just by measuring the preferences of each customer, what attracts these customers or viewers to a particular show, and then showing that as a teaser has helped Netflix grow by 30% just by doing this small little change. Another quite a big example, Flipkarts. Everybody, we know that whenever you are browsing a Flipkarts or the Amazons of the world, you actually tend to see the products based on your browsing history, what you have been searching earlier, and that's one of the ways they actually promote the product. But very interestingly, they also have an anticipatory shipping model. Let's say a product that reaches you in 2 days against a product that reaches you in 6 days, while your need is to use that product in the next 3 days. So Amazon, Flipkart, they use an anticipatory shipping model, which uses a data science to predict what are the products which will be used by a particular demography or a geography. They preempt it, they understand it, and they make a call to send those products in the nearest warehouses to those towns and cities, so that when you are ordering next, you get them as early as possible, making the customer experience rich. That has driven the sales of the product by comparing on an Amazon platform up by 30%, 10% as compared to the same product being bought into the other platform, just by using an anticipatory shipping model. Think about an Uber, a proprietary algorithm. If you look at on a day-to-day life, when you are ordering an Uber, you are actually calling what location, what address you are going to, and what is the nearest driver in the vicinity. He comes to you, but there's a lot of science behind it. Depending upon what kind of customer you have, either you're a 5-star customer, what kind of cabs you have been booking in the past, what localities you have been going in the past, they tend to match the profile of the driver, not just based on the availability of the nearest driver, but also the profile of the driver that meets the certain criteria will be sent across to you. So you get a better experience in a world where you have an Uber in there, you have Taxi for Sure, you have every other platform in there which is providing the personalized service. How the Uber differentiates the experiences by matching the driver's profile to the customer profile. This also helps them retain the drivers by providing those 5-star drivers with the best of the customers they have got on their platform. Think about, I mean, just a food for thought. You are going into a pub, having a couple of drinks, and you are typing, think about it. You are typing on your phone for an address, doing a mistyping, deleting, mistyping on the Uber app, and Uber knows you are drunk. So can it give you a surge price and you are likely to accept? They can very well do it, but it is an unethical form of thing. But can it be done? Think about it. So these are some of the examples which you see in your day-to-day life, which are very much, you are quite familiar with. But apart from that, if you look at it, there are a lot of examples that we can think about it, which are there, which are not visible in your day-to-day life, but where the data science is all active in. My son ordering a dress on a metaverse, but that does not meet my profile. My bank gets alerted. I gets anomaly detection. I immediately gets an alert. I have never said to my bank, do not please alert me if you see, but they themselves are proactively doing, because they have detected an anomaly there. Let's say you go and start playing with your friends on a new metaverse site back again, and suddenly your bandwidth goes for a high. Your service provider improves your network bandwidth automatically, and now instead of having a 40 Mbps line, you are getting a 60 Mbps signal. Why? Because your service providers know you are a gold customer. You are not somebody who's 100 rupees ARPU monthly prepaid customer, but you are a premier customer for them who's paying 1,500 rupees. And if your demand or if your need for the bandwidth has gone up at any point in time, it can be triggered automatically. The rules are configured, and they will come back to you and tell you that at this point in time, you probably need the higher bandwidth, otherwise you would not have that newer gaming experience, and you're more likely to buy that. Your energy consumption prediction, looking at the weather pattern in the states, how collating that data with the availability of sunny days, collating it with how many solar panels are available in the vicinity, and then identifying what would be the typical need on a particular weather in a vicinity, and collating all that and finding it out whether there needs to be a proactive buying of the power from the grid, proactive work that needs to be done on the grid, helps in bringing, managing, maintaining the grid in a healthy shape. Think about, we have hundreds of millions of people who are diabetic and on a verge of losing. I mean, you all know diabetes is one of the major reasons for the blindness. Think about a solution. If you just click on a camera for your iris scan, and I mean, you take a picture of your eyes with a high resolution camera and send it to a system that can actually see whether retinopathy or diabetic retinopathy is setting in. You can do it yourself, send it across to your system, get that results back. You don't need to go to the doctor. You have never been there, but you will still get an alert that you need to take care of your eyes. There is a diabetic retinopathy. How many lives or how many eyesights can be saved just by this simple hack? Early detection, if there is a fire, your system's alerting it, just when it was not a full-fledged fire, but just when the temperatures are rising or a carbon dioxide, and then an event is detected and it happens. So a lot of things which you do not see in your banks, in your electricity providers, with your healthcare providers, with the government doing in the background, they are the decisions which are being triggered through the decision science by correlating millions of data points and making those meaningful decisions in the real time. A simple, I mean, something which you guys will not see, but you will relate to it. Anshul, I know I'm above my time. I think it's another 5 minutes. Do I have?
Okay, fine. You can do go for 5 minutes.
Thank you so much. So we're just talking about one of the use cases a medical device company. It could be any company. I'm just giving you the numbers. So since you guys are going to be the budding engineers going into the industry, I'm telling you what are the kind of proactive use cases, how the industry is getting overwhelmed by the data science and how the data science is saving the millions of dollars. One use case, we are in 225,000 complaints being received majorly through the emails, 80+ member teams looking at it. And yet the customer is not happy because the complaints comes in an email. It takes a lot of time to resolve those complaints and come back. Through the NLP data science, what we did is we brought in we leveraged the intelligent classifications of the email, identifying which are the complaints, which are the appreciation mails, which are really something that will be a mass problem, directing those mails automatically to the right concerned person so that there's no bounce back and thing. A very simple but an elegant solution implemented in 3 months time, and estimated benefits 500,000 USD. And more importantly, the customer experience, where the customer was waiting for 2 days, 3 days to get around his complaint resolved, it's 45% reduced turnaround time. So those are the few of the examples which which the industry is going through, which many a times as a student you would not see, but those are in your professional careers, you will see a lot of such examples that are going to go there. Just last thing, sometimes it backfires. There is a lack of explainability. You go and call them and the system says, yeah, this is what the system generated. So many a times the AI system backfires. So what is the governance around these AI system? There is a lot of government regulations that are being formed around it. And when you are entering into the world of decision science, data science, AI, the most important thing that is coming up is you have to ensure that you design for trust. You have to make the AI or a data science your ally. You have to ensure that you design your algorithm for trust. You are looking for data. You are absolutely making sure your algorithms are not biased towards certain data points. You reduce those data points, and that's something that will drive the growing adoption of the AI and the decision science. That will make way for the growing legislations. That will take care of the unfair decisions, better decisions, and that will, if we go with the design for trust, that is going to be the driving force for the future, where we can confidently say that data science and decision science is something where the future lies. Feel free to ask any questions around these use cases, how they have been implemented, what are the algorithms that are being used, what are the systems that are being used, how it is helping the industry. I'm more than happy to answer those questions. So that's it from me, Panchal and Dr. Bansal. So over to you guys.
If anybody has any queries, you can post your queries on the chat. So if somebody is having any query, they may wish to connect to you offline too, sir.
Yeah, absolutely. They can connect with me anytime offline.
Yes, sir. So thank you so much, sir. Thank you for your enlightening words, sir. It was a pleasure to listen to you give insights about cloud computing and data science. We feel privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new ideas to broaden their knowledge for expanding growth in the field of cloud computing. I believe your words have set new levels of expectations that our students aspire for. On behalf of Amity University, Uttar Pradesh, I would like to extend my warm gratitude. Knowing how busy you are, we appreciate the time you took to impart us with your valuable knowledge. We are highly grateful to you, sir. Thank you, sir. Thank you so much.
My pleasure. Thank you so much for inviting me.
Good afternoon, Ashish sir. Hi, good afternoon. Good afternoon to everyone.
I'm Nidhi Chandra, sir. I'll be coordinating your session. And first, I'll introduce
Thanks.
you, then you can start. Sir, you will be presenting any PPT, sir?
Yeah, I have a presentation.
And so, have you got the right, sir, to share your PPT?
I can check if you want.
Yes, sir, it will be there, sir.
Let me know if it's working.
Yes, sir. Yes, sir. Yes, sir. I can see you.
Okay.
So, sir, we'll start sharp at 2:15, sir.
Sure. You want me to stop the sharing now?
No, sir. No, sir. No issue, sir.
Okay.
Yes, sir. Please stop the sharing. Once ma'am read your profile, after that you please share your.
Okay.
Ma'am, right 2:15 will go live.
Yes, sir.
It has its origins in
Mr. Mohammed, shall I start? It's live.
Wait, ma'am. I'll let you know, ma'am.
That is about
Ma'am, we are on live. You can start now.
principles will remain same.
I feel privileged to welcome you to the Day 2 keynote of Conference 2022. Good afternoon to all the dignitaries, professors, participants, students present today. On behalf of MIT University Uttar Pradesh Department of Computer Science and Engineering, MIT School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for the keynote address.
We are on live. You can start.
Principles will remain same.
I feel privileged to welcome you to the Day 2 keynote of Conference 2022. Good afternoon to all the dignitaries, professors, participants, students present today. Today, I'm happy to take the opportunity to invite our honorable keynote speaker, Mr. Ashish Kumar Adhikari. And Mr. Ashish Kumar Adhikari, Principal Project Manager, Microsoft. He has over 22 years of experience in technology, sales, helping business increase revenue, increase market share, enhance branding, and lower operational cost. His specialties include enterprise consulting, cloud, cybercrime, and strategic investment in emerging companies. The core of this session would be artificial intelligence. Sir, I invite you on the platform to share a few words with us.
Sure, thanks. Thanks, Nidhi. And I think it's a wonderful forum to talk with all the MIT folks and related, I would say, audience to MIT University. So next 15-20 minutes, I'll take you through pretty much what you would know, but you might not have seen it from that view perspective. So let me get a quick confirmation, maybe if you can see my screen, then I can just get into the AI and make
Yes,
you
sir, it is
aware of.
visible. Yes.
Okay, thanks, Nidhi. So if you look AI, it's not new for any of us, I would believe, specifically for the student fraternity who continuously in the past years have looked at courses on AI, and many of you would also taken it. But you might find new in context of the imagination you will get into during the talk as to what it can do. Probably when I first learned about it, I had my own sense of excitement and fear, fear more so in context of what it can do, but equally excitement in terms of, what it can potentially do in coming years. So if you look at AI, and it's a fundamental question, what is AI? And let's, before we go to machines, look at humans, look at, people around you, look at your friends, look at people who are older than you, younger than you, dignitaries who are well known for their mathematical skills, I think it's fairly common for all of us to say, hey, humans have common sense. And sometimes when your friend or your peer is not doing as expected, you say, hey, he doesn't have a common sense. And while we all talk about common sense in fairly intrinsic ways in our life, we also recall individuals with a brilliant sense. And you say, like, whether it's Einstein that comes to your mind, or Bill Gates, or Elon Musk, or Mark Zuckerberg in the tech sector, or other tech folks where you say, hey, these guys have something really, really inspiring to look at, and they really have a great brain, a great intelligence. So and you basically can distinguish. Now imagine if machines starting having common sense. That's a kind of AI we're talking of. And then further imagine if you could create a machine which is brilliant, which is awesome, which is way more intelligent than any human being. And if you've seen some movies, pretty much what comes to my mind is Lucy, which keeps on repeating in various channels, or Transcend. You would really realize that if I knew a lot more as a human, or if machine could do a lot more, then what could be the output of that? And now imagine if machines actually had infinite sense and vision. Because most of the time when we talk about machines, what comes to our imagination is a laptop, a tablet. Sometimes what comes to our imagination is robotic arms. But imagine if a machine could take any form factor. And that's what we're talking of. Machine being able to take any form factor. It could be chatbot, it could be robotic arm, it also could be a car. And we all know, let's say currently the self-driving car are nothing but a clear example of a machine taking a form factor of a car, having intelligence to drive itself. And you really need a lot more than common sense today to drive in India or any other part of the globe. But if you say AI in a true form is where machines themselves are able to drive on their own on the roads. I mean, driving in air is very different, where you have airplanes, and you've already heard of the word autopilot. It was in a way a good early example of an AI. Now, what if your computers can see? What if the computers can come in any form, and not necessarily the machine has to be a hardware only? It could be a software, or it could be a combination of a hardware and software. So if your machines can start seeing, and in humans we're able to see, we can apply judgment, we also have arms and legs to move somewhere, lift something, which is we can also have a way to probably do the task, whether it is talking, playing guitar, or working on a keyboard. So those are the acts that you do. But start imagining now with the AI, you have computers that can pretty much do more than what they can see. But the initial AI bits that you will see in computers would not be so omni capability like a human being who can see and listen and act and judgment. But I can only tell you we're going that path. And if you look, early viewpoints of those paths would be where a machine can see, then it could do a defect detection. So let me actually point to certain examples, which will be easy. Nowadays, we obviously talk about pandemic times and people wear masks. If machine could see like humans, like you walking in a street and you suddenly see a person who's not wearing his mask properly, it triggers an emotion in your brain. And if that person passes just in front of you, you might go a little sideline just to avoid proximity contact with him. Now imagine if a machine could see a person in that way, wearing or not wearing mask. It could count the social distance, it could count the number of people in the queue. And that's part of a medical analysis example if machines start seeing. Now, if you can see a mask, and we all are aware of today that there are cameras when you take your car on roads in Delhi or Gurgaon or Noida, which can do an auto challan, if you will. And what is that? It's a machine which is able to see. It not only sees, it also has ability to actually figure out if you are driving at 60 or 80. Now, if I ask any human being and a car is passing, can you actually tell me what speed it was? We don't have that calibrated way of telling. We can only say it is slow or fast or very fast. But we can't say it's going at 60 kilometers or 68 and be very precise. And you will see a sense here. Machines are way smarter than us. They could have capabilities way more than humans to even figure out the exact speed at which a vehicle is moving. We may not be able to read out the number of a vehicle if it is moving fast, but for a camera on the machine, which is equipped with possibly infrared as well, the machine can even figure out the number in the night, forget, the speed alone. So you clearly see if the machine actually is deployed, it will be very, very effective than a human. Plus, it will have no fatigue. It doesn't need Saturday, Sunday off. It can work seamlessly for hours and hours and hours as long you give the machine its food, and the food for machine is power. So these are some examples, but I hope I've made you see what an AI and a machine and human resemblance and capabilities are. And then if you look at other streams, whether it is defect detection, which you want to identify the defects in reporting or construction or transportation or manufacturing, where a human eye wouldn't be possible to get that. Machines can do that in manufacturing, construction section. You can even look at IoT-enabled cameras, computer vision models to track individuals within a control movement, like in a factory, retail, or a construction scenario. I think today I was reading in the newspaper or some article that the laparoscopic operation, machine robotic arms actually did with zero human intervention, and that's very precise activity that the robotic arm did without the intervention of human. And then it could also do assembly, and most of us would have seen the likes of the companies like Amazon and other large retailers. They don't really need human beings in the warehouses. They are pretty much robots which can lift. They may not look like robot in a human being format, but again, we're going there. And if you are following Tesla, then just yesterday or day before yesterday, the Tesla guys announced pretty much a human-like robot. I'm forgetting the name that they're giving to that. And the human-like robot actually is pretty much similar to, if you have seen the iRobot movie, and that's what it looks like, the robot which is there. And the announcement, I think, looks more like movie. It's called, this robot Tesla is naming as Optimus, if I'm not wrong, and you can search for that as well. So you do see how we are moving there. And this pandemic, a lot of us have also got familiar with the so-called robots who can clean our houses. And how they clean is the robot learns what's your drawing room, what's your bedroom, the size of room. So they have this learning capability to identify so that then they can move. And then they obviously have sensors so that if they're hitting a wall, they can go back, they can figure out. You can also say, I'll have a sofa here. So they pretty much know how to go around the sofa, or there's a center table or a dining table under which you can or cannot go. So all those things you can give cues to robot, which is cleaning your house. And then it also makes a actual kind of sense by start cleaning, and then it starts learning. And why I'm telling you that is, if you take your house cleaning robot to another house, it may not perform as well, but gradually it will, because it has to learn. So the concept is, it's not about capability. So robot had a capability to clean the house. Similarly, I told you earlier in my example, the hardwares, if you look at the example of a car, there are enough hardwares today in our lives with government so that if you are moving past about 60 or 80 as a speed limit, that can detect and then issue a e-challan. But imagine if instead of car, they want to see something else, refrigerator or some other thing loaded on the car, then they'll have to retrain. And again, learning curve will come there. So the idea is, as you look at capabilities, that's one set, but retraining on that capability is what learning is. And that will also take us to machine learning, but let's stay with AI because that's how you'll be able to link the intelligence through capabilities, and then how does it really relates to the learning part. But let's go on the abilities or capabilities first, which at least we define it as computer vision. The different vendors will give different name, but the key is the computer ability to see like human, like we all have vision, we can talk, we have feelings, you can smell, and so on. So what if the computers start getting these capabilities or senses, you will see a different kind of computers then. And here, if you look, I have a diagram. I don't have to go through all of that, but just to give you a view into when you start looking into AI as students, as aspiring people who want to do some research, and you start peeling it, you will look at it needs database, it needs storage, it needs orchestration layer, it needs identities, it needs monitoring, it needs model training, where we cover as part of machine learning. And AI and machine learning pretty much are married in a way that for an AI to be really, really effective, it has to keep learning, like in my example I shared you earlier. And there you will find, is my AI project catering to one business need, or it can cater to multiple business need? And if it can cater to multiple business need, which is a singular function or a multifunction AI, would be driving the need of the machine learning capabilities. And again, once you have what we believe a good AI working, and there can be thousands of examples like I showed in the previous slide, you would need to have dashboards, you need to have some apps which when consume them, and depending on whether you need streaming or not, you will also have the streaming applications along with your AI one. So coming to machine learning, what is machine learning? If you look in the earlier example, we were discussing humans with common sense. And if you talk about how do humans get more sense, can they learn from their past mistake? And the same logic applies to machine learning. And even if there are human with brilliant sense, can they make mistake? Which also points to that if a machine is already loaded with AI intelligence capabilities, and I also give him the training algorithm, which is very, very precise, thanks to machine learning there, then can the machine still make a mistake because it's the best learner in that sense? And if you see machine with common sense, like I said earlier, can they borrow sense from somebody else? Now in humans, you can't borrow sense from somebody. What you can do is you can delegate. But in machine learning, it's very different. You could have a camera, which is a good camera, which you deploy it so that you can monitor a running traffic and issue fines. But your algorithm isn't good, which means your brain wasn't good, which you're applying to camera. The camera can still see from 100 meter, and the camera can still, even if your car is going at a speed of 260 kilometers an hour, it can still figure out a number and decipher it. But if the car is at a 500 kilometer per hour, then the camera fails. But what you're seeing is that your software is not able to still issue challans. And there's a lot of false alarms that it's generating, which means the sense in your camera software isn't so good. So can you actually borrow sense? can you replace it? So the hardware is same, the capability is same, and that's what happens in machine learning. So not only can you learn, but you can also change the model. And there are a lot of companies which are now started mushrooming, which sell this in so-called IntelliSense or leveraging data. They create models. They, based on those models, they can predict accurately, they can work accurately. So now it's not just about the solution, it's also about the sense which can be borrowed or sold in an AI world. And some awesome machines, and when I say awesome intelligent machines, these are the machines which can themselves write more code. Traditionally, we basically believe that the code writing part is done by humans, but currently there are deep coders if you visit. So the code itself can write more code, which is a little fearsome, because then what it writes and what it does, the complexity of that, a number of lines, is very, very difficult to interpret it. And if you're looking at those kind of machines in future, not only they are coding themselves, but they're also learning from the data, and which is what the, I would say, a little scary part as well. But that's all there even today. Just that it'll grow more, it'll have much higher coverage of industries. And ML is when the machine can learn via performing the task, and based on the data it works on, it continuously learn like human, but given it can do millions of things unlike human in a split second, its learning ability would be very high. So this slide will take you to the certain ML models or machine learning models, and you will clearly see that in these models, what is critical is ability to compute, because when you're learning something, you will require a lot of computation, and you will require a lot of data and model drift. Now, so imagine in our same example, if I have to have a new learning given to a camera, then I really need the software in such a way that it can very quickly interpret the car which is going, so that it can figure out the number. So I really need a high computing power somewhere, so that if a video feed is coming, then very quickly I can read the number plate of it, and that will require computational power. And if you're looking at a model which is built to detect the speed, then again, if I was not able to detect the speed earlier, I really need a new model so that it can run on my data set, which is a moving car now, and very quickly, then issue a challan if it is above business rule. So that does require broadly reproduction of the model, validation of the model, then you'll have to redeploy. So this cycle generally you keep on doing as part of machine learning before it's trained, and the model, sometimes you even need the model retraining, wherein you're saying, hey, even the model which I've created really needs some changes for my algorithm to probably work precisely. And again, as you move into this ML, you will have different organizations offering some models off the shelf. So if you're into programming, do I really need these models created from scratch, or can I use some of the ones which are available? And the answer to that would depend on where you want AI ML to play. And when you're looking at AI ML, what is the form factor? Like I said, chatbots can be a super form factor to the AI front end. You really don't need a robot or a machine to be the front end. You can just have intelligent chatbot, and given their intelligent chatbot, pretty much they will be serving the business like restaurants, call centers, a virtual assistant, helping you to park, whether the appointment. So let's say if you want to take an appointment right from a doctor to a saloon, you typically call them and say, when are you free? Why do you really need somebody to do that when you can have a virtual assistant to do your entire appointment management, whether using a voice, a calendar, changing? Yeah, so those are critical things which require too much of human effort, which again can be automated, leveraging the AI and the machine learning. Because if the machine learns that a doctor or the hairstylist doesn't want to give certain times, or certain time slots for appointments, then the machine learning algorithm automatically learns and applies that. Similarly, if you pick up marketing, a lot of time you get product recommendation, customer insights, and some organization, what I've seen today, the early are looking at cash flow forecasting, financial forecasting. Then you would have this predictive maintenance, demand forecasting again. And curiously, I've recently also seen where companies are using these models to understand whether the employees are healthy, are they enjoying their job, or would they be quitting. So again, those models are also available. But as you see now, this ML modeling is not just playing a role with respect to giving intelligence to the AI aspect of the software that you're building, but it's also leveraging the entire data cycle, depending on the vertical, letting you predict or do an interaction like chatbot, and delivering a true outcome to your business. And once those outcomes are delivered, it pretty much results either into some satisfaction score or sales forecast accuracy or customer experience, or decreased fraud. So that's what you can read out, that all of those interactions on AI ML are not just academic in nature. They actually have a true impact on the business as well. Some outcomes, depending on broadly industries, as I spoke about, self-driving vehicles, mobile pieces, picking robots, which are used in inventory, chatbots used in customer service, manufacturing, we spoke, defect detection and supply chain management. And we're also seeing emergence of teaching robots. And this is way more than just going to, let's say, Edureka or other websites and seeing videos. So those teaching robots are also very innovative. They actually ask you certain questions to figure out at what level of education maturity you are in a subject. So if you were saying, I want to do programming in, let's say, .NET, then they'll ask you basic questions to figure out where you are. And those 4 or 5 questions, like any human teacher, will assess whether you are in stage 0, 1, or 2. And then they start actually teaching you from that stage, and then even taking some more questions. So a teaching robot phenomenon also in education is amazing. And the robots can also now come in form factor of a 3D avatar, which is what metaverse would move into. And as you see, it's all powered through the AI ML, because what was powering the robot was the machine learning language in the teaching robot case also, which based on hundreds and then thousands of students, it has probed and then given some courses, and then based on those course and video recommendation, again taken a question check, really changes. So again, what comes to your mind is, hey, if I have these teaching robots and if I'm teaching somewhere, whether in university or school or other academic institute, so what happens to me? And how do I, work with and play in that environment, are the questions that would come not only in this segment, but pretty much every industry that robotics, automation, AI, ML will pick, including, the likes of what we see today in our industry, the food delivery. So what if tomorrow drones start delivering food, and automated vehicles come and they start delivering the food for you from Zomato or Swiggy? Then what happens to these thousands of people who today are running on the motorcycles and delivering food? So all of that would come to your mind. But I think the topic of today is not on the jobs, but it's more to do with where AI and ML is and where it is going. So with that, pretty much we come to an end. I hope I've given you a good view into the AI part, the ML part, where it is going, and also some examples. And I'm sure now you will start thinking in terms of what if these super capabilities start coming in machines, how would they start acting there? So with that, Nidhi, thank you. I hand it back over to you.
Thank you, sir. It was a pleasure to listen to you on the subject of AI and machine learning. And I extend my regards for your talk. And on behalf of MIT School of Engineering and Technology, I would like to extend my warm gratitude, knowing how busy you are. We appreciate the time you took to impart us with your valuable knowledge. We are highly grateful to you to have you with us, sir. Thank you. Thanks a lot, sir.
Sure. Thank you. Thank you, everyone.